హలో. అయిపోయానన్నా. రైట్. Okay, good evening. Can you hear me? Good evening. Good evening. Can you hear me? Okay. So the last two problems we are going to repeat once again because yesterday there was a lot of disturbance. So let's repeat the last two problems, right? Now, when a circuit like this is given, this is a gate problem, as I told you. How do we calculate V naught? We all know that if Vin is Vm sine omega t, the capacitor will charge to the peak value Vm. But once the capacitor charges to peak, thereafter the diode will remain reverse bias because there is no chance for the input Vin to cross more than Vm. So once the capacitor is charged and there is no discharge path for the capacitor, we have seen that the diode will allow current only in one direction. In the opposite direction, it cannot discharge, so it can only hold that charge. So what happens during positive cycle? During positive cycle, I told you positive cycle means the current is flowing in this direction from plus to minus. So during positive cycle, D1 is on. D1 is on. And what is this capacitor voltage here? VC1. So what is the maximum voltage Vin that you can give? Vn max is going to be Vm. The diode is on. And here you have VC1. Let's apply KVL. It is minus Vm plus VC1 equal to 0. We have seen that the capacitor will charge to peak. If the input voltage is 1 volt, capacitor will charge to 1. Input voltage is 2 volt, capacitor will charge to 2. If input voltage is 5 volts peak, then the capacitor will also charge to peak. But after the capacitor is charged, thereafter input cannot cross more than Vm. So the anode voltage cannot be more than cathode. Therefore, the diode will remain reverse bias thereafter. Because if you say that the diode is forward, then I have to say that there is a flow of current. If you say there is a flow of current, that means the capacitor should still charge. So that cannot happen because the capacitor has already charged to Vm, right? Now, what happens in the negative cycle? I'll change the color of the pen. For the negative cycle, the current direction is reverse, right? So when it travels like this, can it choose the path of D1? Can it choose VC1 and D1? No. It has to choose this path. Am I right? It has to choose this path. Then what is this voltage here? Now this capacitor has charged Vm. Now this is flowing in the opposite direction. I told you the polarities will come only with the direction of current. So if you take a plus minus here, this is also going to be Vm, like VC2, right? So let me write this here. During negative cycle, D2 is on. D2 is on. When D2 is on, then VC1 is going to be Vm in the opposite, right? So similarly, you can apply KVL if you want, right? Now, after the capacitors are charged, the diode remains reverse bias. After the capacitors are charged, the diodes will remain reverse bias. So here it is Vm because of this current direction. It is Vm in the opposite. Now what is KVL here? Minus Vm plus V naught minus Vm is 0. So your V naught is going to be 2Vm. Your V naught is going to be 2Vm. Suppose the sine wave has got a peak value of Vm, then what is 2Vm? It is going to be peak to peak value. 2Vm, it is peak to peak value. VC1 detects the positive peak, VC2 detects the negative peak. So your V naught is going to be 2 times when you take the difference. So during positive cycle, D1 is on. The voltage here is that instantaneous voltage, this voltage. This voltage is a maximum voltage Vm. This voltage is going to be the maximum voltage Vm, which we have given. In the negative cycle, what happens in the negative cycle? In the negative cycle, this voltage is going to be negative Vm, right? Negative Vm, and here you have the capacitor, VC2. So similarly, you can apply KVL around this loop. Vm minus VC2 equal to 0. Your VC2 is going to be again Vm. So this is VC1 and this is VC2. Your VC2 is again going to be Vm. So the difference is now going to be this polarity. The difference is going to be 2 times. Now, what if we apply the same technique here? But this time, during positive cycle, when the current flows like this, it has 4 paths for it to flow. So what we have to do with the pen, right? Don't stare at the circuit. You have to take a pen like this, and you have to draw 4 lines like this. This is one line. This is another line. This is another third line. And this is the 4th line, right? So you have to draw like this, right? Don't stare at the circuit. You keep on staring, the circuit will be there only, right? So when you draw lines like this, you should see in which direction the current will flow, right? Because current will always choose a closed path. But don't draw lines, like this. You should never draw. For example, it goes into D2 and then goes to D1 and stays here, and it will never come back home. Are you getting? You should not draw. When you start from home to the market, you should not get stuck in the market, right? At least when I was as a kid, right? Maybe I was in my kindergarten. That was my birthday. I went to buy chocolates and I stayed there, right? I never came back. Then few people had to, bring. So it was a whole mess. I still remember that, right? Don't do that. There should be a closed path. Closed path means what? You should start from home and you have to come back home, right? So don't go through D2 and then D1 and then D2, D1, D2, D1. Current is nicely flowing from anode. You should never do that. So this is all wrong. right? Don't do this. Is child's play, right? You should never do this. Now we are matured enough. We know how to come back home, right? When you start from home here, you have to, when you start from plus terminal, you have to reach minus. So how many ways are there to reach minus? You have to say, right? Don't get stuck in the other loops. Our main aim is to find the quickest path. So because current is like that, current will always choose the quick path. It's not like you find the shortest path, don't go in some other route and then get stuck, right? So what is the shortest path to reach the minus terminal? So there are 4 paths now. One is through the capacitor and then D3, right? Quickly, you can go through the capacitor and D3. The second one is through D1 and D3, through D1 and D3, and then to the minus terminal, right? Quick. The third path says that it is D2 and D4 and then the minus terminal. The fourth path says that the capacitor and the D4. From plus, you start from the capacitor, then D4. Now you tell me which one is, and what is the rule now when you move from plus to minus? You should always choose anode to cathode. You can never travel from cathode to anode. Current will not flow from cathode to anode. So in the positive cycle, what we have to do in the positive cycle, now there are 4 paths. First, I'll try the capacitor, right? I'll try the capacitor. So can I go like this? Yes, I can go, right? I can go through the capacitor and D3. That is one thing. Next, can I try D1 and D3? No, current cannot flow through D1. So this is okay. This current does not flow here, right? Next, can it go through D2 and D4? No. Can it go through the capacitor and D4? No. Current cannot flow through D4 because cathode comes first. So it cannot go like this. So this is wrong, right? This is also wrong because D4, maybe D2 is on, right? We might primarily think D2 is on, but current needs a closed path. So what if this D4 is an open switch? Current cannot flow. So there's only one path for it to flow. What is a single path for it to flow now? What is a single path? During positive cycle. During positive cycle, right? Only one diode is on. D3 is on. That's all. During positive cycle, only one diode, D3 is on. It cannot go to D2 because D2 there is cathode, right? So, okay. So if this is the current direction, then this is the polarity VM. This is the polarity VM. And after the capacitor is charged, the diode remains reverse bias. After the capacitor is charged, the diode remains reverse bias. That is okay. Now let's try the negative cycle. Let's try the negative cycle. What if okay, I'll change the color of the pen here. What if the current direction is in this fashion? Any other color? What if the current direction is in this fashion? In the negative cycle, that is a positive cycle, in this cycle, then how the current is going to travel? Can it go through D3? No, current will always choose anode to cathode. So it can't go to D3. So then it's ruled out whether it has to go through capacitor or D1, it's ruled out because D3 is off. Can it further go through D4 and quickly reach the plus terminal? Maybe, right? Through D4, it goes here, meets this node. It has 2 paths for it to flow. Now tell me, which one will it choose? Will it choose D2 or will it choose the capacitor? Naturally, it will choose the capacitor and reach home, right? Reach home. So during negative cycle, which diode is on? D4 is only on. D4 is on. So Vin is Vin, but the current direction has changed. Now, after charging, diode is reverse bias. After charging, the diode is reverse bias. Now, let me draw the two capacitors here. There is one capacitor here. There is the other capacitor here. And you're taking V0 in the middle with this polarity. So with this polarity you have Vm, and with this polarity you have Vm, right? So now you can apply KVL. So what is KVL? Minus to plus. When I go from minus to plus, I'll always take the first sign that comes. Minus Vm minus V0 is 0. So your V0 is going to be minus 2Vm. Your V0 is going to be minus 2Vm. So what are the two diodes that are on during positive cycle? Capacitor D3 and Vin. Plus terminal, capacitor D3 and then minus terminal, right? So the current is going to choose this shortest path during positive cycle. During negative cycle, from minus terminal, how will you reach plus? During negative cycle, from the minus terminal, what is the shortest path to reach plus? And don't get stuck somewhere in the middle, right? So you go from minus terminal to D4, and from D4, choose the capacitor and then reach the plus terminal, right? The capacitor other end is connected to the plus terminal. So this is the shortest path for reaching where? The minus, right? So this is the shortest path. This way you will reach the plus terminal from the minus. And after be careful with the polarities of the capacitor. They come with the direction of current. So the current was in this direction for positive. The current was in this direction for the negative, right? Current always flows from higher potential to lower potential. So finally, your voltage is going to be 2 times Vm, 2 times Vm. Current can see for current to flow, this is a path, right? This is a path. Current, this is the correct path, right? If current is like this way, is a wrong path. Current will not flow. This is anode. This is cathode. Current always flows from anode to cathode. Current will not flow from cathode to anode. This is wrong. Are you getting? Current always flows from anode to cathode. Current does not flow from cathode to anode, right? So I took two currents. This during positive direction, this is the current from plus. During the negative direction, this is the current, right? And current always finds a path from anode to cathode. So after the capacitors are charged, and after that, naturally, all the diodes are what bias? Reverse bias. The two diodes are reverse bias, and the other two, they are already reverse, right? So this is a foundation for next topic. This clamping, when we are doing, the first step in clamping is to find the capacitor voltage. The second step is to just replace the diode by open switch, and we will sketch what happens across the diode. Across the diode, if you sketch, you will find that you will get some sort of a clamped output that we will see later, right? Now our main topic is only across capacitor. Only across capacitor. Okay. Now the first two circuits we have seen, which I have drawn yesterday. Today, I am giving you another two circuits. Now take the pen and try to move your hand like this. Then you will know. See that your hand should start from plus and it should reach minus. Your hand should start from plus. It's like child's play, right? Take the pen, put it at plus terminal, see how your hand will come back to the minus. Don't get stuck somewhere, in the loop, and you have to reach home. That is more important. Start from plus, let the hand move like this, right? See here, all of you see here. I'm starting from here, right? Like this. Slowly. Is it difficult to move? Slowly you have to move like this, right? Like this, slowly, like this, la, 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 like that, right? Slowly move and come here and stop your hand there. And your hand should move only when there is an anode terminal, right? Can it go through D1? No, it can't go through D1, right? This is ruled out. But can it flow through capacitor? Maybe. So you have to move like this, slowly move, right? Is it difficult to move your hand like this? No, isn't that? Like this, right? And then come to anode. So current will flow from anode to cathode. Once you reach here, this node is nothing but the minus terminal. He says, okay, bingo, right? So this is how you have to move your hand, right? Now, this is one loop, right? Can we have one more parallel connection? Let's see, can we have one more parallel connection? Again, start from plus, go there, go a little further and see if you can go here. No, stop. Are you getting? You can't. This is right. This is correct, right? So slowly move here. Don't stare at that circuit. Move your hand. Move the pen like this. Slowly move the pen. Right? Is it difficult to move? I once more. I will move, right? Like this. Slowly. Like that, right? La 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 la. You can sing also. No problem. Right? We should get the answer ultimately. Right? It's like that. La 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 like that. Right? Slowly. Should come to the minus. It doesn't matter. Right? So this capacitor, the first one, this capacitor is going to charge, D3 is charging, D1 is reverse bias, right? Of course, D2 is also reverse bias. So what can I write now? During positive cycle, who is on? D3 is on. When D3 is on, with this direction of current, you'll have Vm. Are you getting? Now, what happens during negative cycle? During negative cycle. Now, the only difference is you have to move the pen in the opposite direction. That's all, right? Slowly you have to move. So let me move the pen like this. Slowly. Any problem? No, right? Slowly you move the pen. You should always go from anode to cathode, not cathode. Current will flow from anode to cathode, right? Can it go like this? No, it's not anode, right? Say sorry, D3. We are extremely sorry. Come here. Oh, sorry, D4. I can't, right? So let's see the capacitor. Maybe we'll try. Go like this and like. Can you see? Right? So you have to move the pen. That's more important. That's how I have learned these circuits, right? Don't stare at the circuit and don't apply a lot of things, capacitor, charging, diode, this, that, PN junction, nothing. Analog is all about voltages and currents, right? This is a design course, not a device course. Okay, so what do we do now? This is Vn. This is a current direction. It went all the way here and then like this. So it has to reach from negative to the positive. So polarities will come only with the direction of current. Am I right? So after the capacitors are charged, okay, let me write, what diode is this? It's D3. And what is this diode here? It is D2, right? It is D2. After the capacitors are charged, the diodes remain reverse bias. After the capacitors are charged, diodes remain reverse bias. So what equivalent shall we draw? So you have a capacitor here. This polarity Vm. Here you have V0. Yeah. And then, there's one more capacitor down with this polarity. But all of you, KVL means the algebraic sum of voltages in a loop should be 0. So how does a loop form here? So this capacitor is hanging on. Let's see where this capacitor is connected. where this capacitor is connected. It's connected to the source. In the previous example, what happened in the previous example? You had capacitors side by side, so they were able to form a loop, right? So within them, we were able to form a loop here, right? So there's no inclusion of V. But here, your capacitor is up and there's a capacitor down, and two plates are hanging on. So this plus is connected to the plus terminal of V, and the plus terminal of this voltage capacitor is connected to minus, right? Okay. So give me a KVL round the loop. What is KVL? Minus to plus, minus V plus Vm plus V naught minus Vm is 0. So your V naught is going to be V. So what happened here? The capacitor voltage, the capacitor that was up and the capacitor that is down, they are trying to cancel in that loop, right? So your output is always following input in the steady state, right? So try moving that pen slowly, right? Slowly move the pen. So this is the first loop, right? There's no loop here. So the first loop is the red one and the second loop is the blue one, right? So there was one loop like this. This is a capacitor, right? Positive cycle. Here we have a capacitor and D3. Negative cycle, right? There's a capacitor here and D2, right? Okay. Now, what about this problem? What about this one? Shall we move the pen slowly? Yeah, tell me. I'll start from positive. Right? I have to reach negative. That's my aim. I have to start from positive. I have to reach negative. Don't draw a straight line between the 2 points, right? Okay, bad joke. So I'll start from plus. I have to reach minus, but I have to go round and round. I cannot, right? So I'll go slowly. Slowly move the pen, move the pen, move the pen. Now I have 2 paths for me to flow, right? One is through the capacitor, the other one is through the diode. Okay, so what if I try taking the capacitor? If I try taking the capacitor, here I have D3. So D3, the first terminal here is cathode. So I have to touch cathode to anode. So this path, capacitor path, is not a valid path. What about D1? Maybe I can reach through D1, But again, I have the same problem. This D3 is what bias? Reverse bias. So when it's reverse bias, it's almost like you have one switch on, the other switch off. Can current flow? Current cannot flow, right? So even if one switch is on, the other switch is off, the current cannot flow. So this capacitor path or D1 path is invalid. So what do? I have to move the pen slowly like this. But then I still have the same problem. What is the problem? I cannot move through D2 because when I cannot go through D3, I cannot go through D2 also because this is the cathode terminal, right? So what should I say now, right? During positive cycle, all diodes are off. All diodes are off, right? Maybe one is on, but no current is going to flow. That's the point, right? It's understood that, right? When no current is flowing, please, a diode off does not mean anode to cathode. Diode off means current zero. So even when the switch is closed and the other one is open, the current is zero. When the current is zero, you will say that the diodes are what bias? Reverse bias. So even if there are 10 diodes in the forward direction and one diode in the reverse direction, it's understood that no current is going to flow in that path. When the current is zero, that means the diode is what bias? Reverse bias, right? Reverse bias. Okay. So bad luck in the positive direction. Let's try in the negative direction. Let's try in the negative direction, right? So let me move the pen slowly from the minus terminal like this. Okay, I came here, right? So I can as well go here also, but first let's try this path. Can it go through D3? Yes, definitely. But after reaching D3, will it go through D1? Will it go through D1? No, because D1 is the first terminal that it encounters is cathode. So it cannot go through D1. It has to go through the capacitor. It has to go through the capacitor. That is one path. The second path is, these are parallel. You have to try both. Can it go here? No. D4, cathode. Can it go through the capacitor? Yes. Like this. So one is like this. This is a capacitor. And then the D3, right? Negative cycle. And then the other one, right? This is D2. And then the capacitor here. So now you're reaching from minus to plus, right? Okay, so let me draw an equivalent here. This is Vn. The current is flowing in the opposite direction. D3. Like this. D2, right? When it flows like this, is Vm. Vm. Okay, right? Now what happens after the capacitors are charged? What happens after the capacitors are charged? After the capacitors are charged, the diodes are reverse bias. Am I right? The diodes are reverse bias. So how should I draw this? Vn. This is the polarity. So V in is V in, right? Don't change the polarities of V. Some students, they change the polarity for V in, right? So they say for positive cycle plus minus, for negative cycle minus plus. What is the problem if you do so, right? If you do like that, then I would ask you, what happened to the zero? You didn't replace by short, right? Because V in has all the voltages, not just positive and negative. It has even zero also. So V in is V in. It can be 0, 1, or 2, or 3, or 5 peak, then all this, right? During positive cycle, the current will go from plus to minus. In the negative cycle, the current will reach from minus to plus. So V in is V in for KVL. The current direction will change, right? Now let's apply KVL. Let's apply KVL. Tell me. Let's apply KVL. Minus to plus, minus V in minus Vm plus V naught minus Vm is 0. So your V naught is V in plus 2Vm. Your V naught is going to be V in plus 2Vm. So this is a gate problem. So during negative cycle, which diodes are on? D3, D2 on. D3 and D2 are on. After the capacitors are charged, the diodes are reverse bias. So I've given you 4 combinations of circuits, right? Now you might ask, if only 2 diodes are charging the capacitor, why did the examiner is giving you 4 diodes in the problem? Just to confuse you, right? 2 are always dummy in every problem. Because for each capacitor to charge, there's only one diode that is helping, right? At least not, definitely not the diode in parallel with the capacitor, right? So current will flow in series. So the diodes that are helping the capacitor are always in series, at least not the one that is across the capacitor. So in the positive cycle, what is the path here? From plus to capacitor and D3. Please don't go through D4. If you go through D4 and then D3, then I told you, I'm going from D3 to D4 and then from D4 to D3, I'll get stuck, right? Never do that. In positive cycle, you start at plus and then reach minus. This is one path from capacitor to D3, right? Wherever you find a diode and a capacitor, see that you quickly reach what terminal? Minus. This is one parallel path. This is the another parallel path. Are you getting? This is one parallel path. This is another parallel path, right? So it's almost like, I don't know, it's almost like, yeah, it's almost like I have a voltage 5 volt, right? I said, what is the path? You have to do like this. And then because of this, I have another path, right? Then again like this. Are you getting? Right? What happens if you neglect the minus and go from the resistor to this resistor like that? If you go there, you get stuck and you never reach what terminal? Minus. So that is more important. You should start from plus and then reach the minus terminal. That is when you can apply KVL round the loop. That is the shortest path. Because the problem is, if you go from if suddenly you reach from D3 and then to, well, what if you go again to D4? D4 you cannot go, right? So it's like capacitor and D3. It's like capacitor and D3. That is positive. Negative cycle, it's this capacitor and then D2, capacitor and D2. Move the pen slowly, right? Please, after you move the pen and form a loop, just remove your hand from the book and see how you have traced that line. See whether that line makes some sense or not. It's not just moving the pen and closing the book. After you trace that line, see if that line forms a closed path from plus terminal to minus. Does it make any sense, right? That is more important. Tracing means you should start from plus and then reach the minus. That's more important. Okay. Fine. So this is the first step, is to find the voltage across the capacitor. Now we'll focus the voltage across the diode now. What happens across the diode? These circuits, as I told you, they are called clampers or clamping circuits. So what is a clamper? Clamper is a circuit which adds DC to the given input waveform. So what will happen if you add DC to any sine wave? Any sine wave. Suppose you have a sine wave like this, 0. This is 5 and minus 5. This is your V, right? So now suppose my V naught is Vin plus 3. How will the waveform be? You have to take every voltage and add how much voltage here? 3. 0 plus 3, 3, 1 plus 3, 4, 2 plus 3, 5 plus 3, 8. Again, minus 1, minus 2. Or you can apply mathematics, right? What is V in range? V in range is going to be minus 5 to plus 5. So what is V naught range? V naught is going to be minus 5 plus 3, that is minus 2. 5 plus 3 is 7. So your V naught is going to have a new DC. What is that DC? It is V in plus DC. So the new DC that you're restoring is 3 volt. 3 volt. And where is the wave moving now? Where is the wave moving? It is moving from minus 2 to 7. It is moving from minus 2 to 7. So when your Vin reaches 5 volt, your V naught is reaching 5. Oh, is it 5? What is 5 plus 3? 5 plus 3 is 8, right? 5 plus 3 is 8. What is minus 5 plus 3 is minus 2. Okay, but how did I get that idea? That I made mistake here, right? It's not because I substituted here. It's because your V in peak to peak should always be equal to your V naught peak to peak. So we are not amplifying the signal. It's the same signal. That is, what is the peak to peak value here? 5 minus of minus 5 is 10. What is 8 minus of minus 2? That is 10. So the peak to peak value of V in is equal to the peak to peak value of V naught. Is the same signal. Shifted up by how many volt? 3 volt. There is no change in the peak to peak, right? So that's how I came to know that I made a mistake here. Anyways, minus 5 plus 3 is minus 2 and 5 plus 3 is 8. So your V naught range is going to be from minus 2 to 8. Your V naught is going to be from minus 2 to 8. So clamper is a circuit which adds DC to the given input waveform. And you can see here that it restores DC throughout the waveform. Throughout the waveform, what is the DC of V in? 0. What is the DC of V naught? Is 3 volt, right? It is also called a DC restorer, right? So it doesn't mean that you have to shift only in the positive direction. You can even shift in the negative direction. You can even shift in the negative direction. Right? So clamper is a circuit which adds DC to the given input waveform. It is also called a DC restorer. Okay. So there's no amplification here. Amplification means what? Stretching the signal, making a small signal as a big signal. That is amplification. What is clamping? You have a waveform like this, just push it to a different DC value such that the peak to peak voltage of output and the peak to peak voltage of input both are same. Now, how do we solve clamping circuits? Two simple steps to sketch the clamped output. Two simple steps to sketch the clamped output. Step one. Step one we have already seen. Find the capacitor voltage VC in its steady state. Find the capacitor voltage VC in its steady state. This is the first step. This, of course, we have seen Vm minus Vm, right? So all the combinations we have seen. What is step two? Step two also 50% we have seen. The other 50% we are left, right? Only sketching we have left. Step two is what happens after the capacitor is fully charged? The diode will remain reverse bias. Tell me, a reverse bias diode is replaced by open switch or closed switch? Open switch, right? Naturally it is open switch. So the second step is that replace diode with open switch, and sketch the waveform. Sketch the output waveform. Find the capacitor voltage VC in its steady state. Replace the diode with open switch and sketch the output waveform. Why we have to replace the diode with open switch? Because the diode is what bias? Reverse bias. We know after the capacitor is fully charged, the diode will remain reverse bias. So these are the two simple steps we are going to apply now to sketch the clamped output. Okay. So let us take the first problem we have already done. Sketch the clamped output in steady state. Sketch the clamped output in steady state. Diode is ideal. Diode is ideal, right? So let's, what is the first peak detector we have taken? The first peak detector. The first peak detector was, yeah, first peak detector was an input, a diode, and a capacitor. Am I right? Right? This was the peak detector. So first the capacitor will charge, after that the diode will remain reverse bias. Now you have to sketch the output here, right? But okay, we can draw like this also, but it's customary that output should always be on the right side, input should always be on the left side, right? Output should always be in the right side, input. So the same circuit, let me draw it like this. In capacitor, diode. The same series circuit, it doesn't matter. And the output is across the diode. It looks better, right? It's nothing like that. You can take here also. But generally, when we look at a circuit, our mind, is trained like this. Inputs are on the left side, outputs are on the right side. Am I right? Yeah. So sketch the clamped output. So how are we going to sketch the clamped output? Vin is Vm sine omega t. Oh, we have taken Vm sine omega t. No, shall we take some values, right? That's better. We'll take some values. 6 sine t. We take 6 sine t. Is it okay? Yeah. 6 sine t, right? So your input, where is your input now? Your input has a peak value of how much? 6 volts. 6 volts. Okay. Okay, right? Shall we start? Yeah. Step 1. Step 1. What is step 1? We'll go back and see. What is step 1? Find the capacitor voltage VC in its steady state. That is step 1, right? Step 1, find VC, right? Tell me capacitor charges to what value? Peak value, max, P max. What is the maximum positive input? Please, by the polarity of the diode, this diode is forward biased during what cycle? The diode is forward biased in what cycle? Diode forward biased in what cycle? Positive cycle. Good. Positive cycle. So what is V in max here? 6. This is the capacitor. We know the polarities. This is your capacitor voltage VC. Diode is on. Right? So give me a KVL. KVL. We know it charges to peak, but assuming that we have not studied the peak detector. So I'm doing both the steps, right? I'm assuming that it's something like a student has joined just now, right, today, and he has not studied peak detector. So for him, 2 steps, right? First, VC. What is the maximum VC capacitor voltage, or sorry, input voltage? 6 kVA. Minus 6 plus VC is 0. VC is 6 volt. So capacitor will charge to peak. We already know that. Fine, it charges to peak. This is first step. What is second step? What is second step? Let's go for second step. Step 2. Replace diode with open circuit, right? Open switch, right? So why we have to do it? This is my Vin. Capacitor has already charged to 6, and we have a diode here, and we want the diode to replace with open switch. So please tell me, if cathode is at ground and anode is a V0 here, anode is at V0, why the diode is reverse bias? Huh? Does it mean that your anode voltage is greater than 0 or less than 0? What do you mean by that? Is the anode voltage greater than 0 or less than 0? If it is greater than 0, if anode voltage is greater than 0, then the diode would have been forward. But now I'm saying diode is reverse. So maybe your anode voltage is less than 6. Maybe. We don't know, right? So let's see. Give me a KVL here. Minus to plus. Minus Vin plus 6 plus V0 is 0. V0 is Vin minus 6. Yeah. How do we sketch this? You can take all the voltages V in and sketch. That is one way. Or what is V in range? Sine wave. What is the sine wave range? The sine wave range is minus 6 to plus 6. What is V0 range? I don't know. Today I'm very, very happy, right? Why am I happy? Because my internet problem seems to be solved, right? So I'm very happy. So let me continue in the happy mode till the last class, right? So what is V0 range? Tell me. Let me substitute minus 6, minus 6, minus 12, 6 minus 6. Vin is 6, 6 minus 6 is 0. Your V0 is going to go between minus 12 and 0. And what is the new DC that you have restored in the waveform? It's minus 6, that's given here. Vin plus VDC is clamping. What is the new DC, right? The DC is not a positive number, it's a negative number, right? And let me cross check if my answer is correct. Cross check, right? What is V0? Vin peak to peak. Vin peak to peak is 6 minus of minus 6, that is 12 volt. What is V0 peak to peak? It is between 0 and minus 12, so that's 12 volt. Am I right? So tell me, Vin peak to peak and V0 peak to peak, both are same. But what is the difference in this waveform? In the input waveform and this waveform, the only difference is the signal has been pushed down. It's like hammered down, right? You can take a hammer. So can you see this point here, right? See this point, this point. So at here, at this point, you just take a hammer and hit tung, tung, tung like that, right? And then you push him right down, down, push him down, right? Hammer him down, right? Don't stretch the signal. Stretching a signal is amplification, right? The peak to peak voltage is same. Vin peak to peak is 12, your V0 peak to peak is also 12, right? This is a simple clamper. Now, how can we avoid these two steps and directly draw the waveform? Suppose I want to avoid these two steps and say that the moment you find a circuit, just draw, that's it. How can we do that? Huh? I've given you two clues now. With the clue, you can draw. I've given you two clues. With that clue, you can easily draw. What are the two clues now? What is your observation? What is your observation? Huh? Very good. I've seen someone writing, is it compulsory that the diode will remain reverse? Okay. If it is compulsory, then cathode is ground, anode is less than 0. So see here, your V0 is less than 0. So you have a voltage that is less than 0, but the peak to peak at output and the peak to peak input is same. So just go draw the waveform, that's it, right? For example, see here. Okay, if you I'll follow both the steps, but I'm just telling you how to quickly draw. Sketch V naught in steady state, right? So you can see here, have you observed that your anode voltage is less than the cathode? Anode is V naught, right? So sketch V naught in steady state. The diode is ideal. So this is your V in. Say, for example, I have a network like this. This is ground. You have V naught, and your V naught is the anode voltage, right? For a change, let me give some input like this. You can take a peak value of 10, this is minus 10. Now, before we follow the two steps, can we directly draw it from the observation we had in the previous day? What's the observation? First, let me write the observation, and then we will do the normal procedure, right? Observation. First observation is your V naught peak to peak is equal to V in peak to peak. What is the peak to peak voltage here? 10 minus of minus 10, that is 20. The second, I've shown you that the anode cathode is at 3. Here we have V naught, and the diode should be reverse bias. Okay, if the diode is reverse bias, what is your V naught? If V naught is greater than 3, imagine V naught is greater than 3, then what is the diode? If V naught is greater than 3, then the diode is forward, but we don't want forward, we want reverse, right? So V naught should be less than 3 volt for the diode to be reverse bias. Okay, so two clues you have got. What are the two clues? If you have a waveform, then the V naught should be less than 3, right? So this is 3, this is 3. And you should have a waveform which is down 3. Please, the portion up is a positive voltage. The portion below is negative. Just draw the waveform now. Just draw that. See here. You have to see here. Can you see my hand like this, right? So can you see my hand like this, right? So I'm just putting it on this portion of the waveform. Take that waveform and then fix him down at 3 volt, right? So here you have to draw here, right? You have to draw somewhere here. Okay, what is 3 minus 10? What is 3 minus 10? 3 minus 7. Minus 7. So you can draw like this. Okay, what is minus 7? Minus 7 and then add 10 to it, minus 17, right? Something like this. So your waveform should be down. Okay, the peak to peak, oh, I forgot this 20 here. I've already written 20. What is 3 minus 20? What is 3 minus 20? 3 minus 20 is minus 17. So you have to push that waveform down to minus 17. So that is basic observation. So what is your observation? One is the peak to peak voltage should be 20. The second observation is whatever the waveform that you're pushing it up and down, it should be less than 3, right? So that's the observation, but we'll follow the procedure. We'll follow the procedure, right? Okay, sorry to disturb you, but is my internet working fine? Is my internet working fine? Is my internet working fine? Nobody's answering. Yeah. Thank you. Oh, somebody's saying fabulous. Oh, thank you. Thank you very much. Okay, so let's follow the same procedure now. What's the same procedure? Again, I'm repeating. First step, find the capacitor voltage in steady state. Second step, okay, what is the procedure? First step, find the capacitor voltage in steady state. Second step, replace the diode with open circuit. So we're going to follow that procedure, right? Step one. Step one. What is the maximum input in the positive? V in max, the positive is 10 volt, right? We have a capacitor, diode is on. Don't forget the 3 volt. Don't forget the 3 volt here. Capacitor will always charge to the potential difference. The positive plate is experiencing 10, but the negative plate is experiencing 3 with respect to ground. So what is 10 minus 3? 10 minus 3 is 7, right? So that we can get by KVL. KVL. Kirchhoff's is there, right? So why do apply our brain, right? Kirchhoff will give you that balanced equation, minus to plus, minus 10 plus VC plus 3 is 0. Your capacitor is going to charge to 7. Okay. What is step 2? After the capacitor is fully charged, the diode is going to remain reverse bias. A reverse bias diode is replaced by what switch? Open switch, right? So I'll put a diode. What is that? Why it is reverse bias? Let's see why it is reverse bias. It's reverse bias because the V0, this V0, which is the anode voltage with respect to ground, is going to be less than 3 volt. Is going to be less than 3 volts. So let me give a KVL to the outer loop like this. Outer loop. Right, the outer loop, and tell me what is KVL. Minus V in plus 7 plus V0 is 0, and minus V in plus 7 plus V0. What is V0? It is V in minus 7. So the capacitor charged to an instant of V in. But please don't forget, V in is not 10 volt, please. What is V in? V in goes from minus 10 plus 10, minus 10 plus 10, minus 10 plus 10. Is some kind of a triangular waveform. It goes minus 10 plus 10, minus 10. But it charged to 7 volt when V in was 10. Your capacitor is charged only to 7 volt, right? It's okay. What is V in range? V in range minus 10 to plus 10. What is V0 range? Tell me. Minus 10 minus 7 minus 17. 10 minus 7 is 3. So your waveform is going to shuttle between 3 volt and 17 minus 17 volt and minus 3 plus. And what's the DC that you have restored here? It is V in plus VDC. The new DC is going to be minus 7. Please remember that DC is always across the capacitor, right? It's across the capacitor. And just draw the waveform. All of you, please don't do transient analysis here. What happens at the first cycle from where the signal is starting, and don't do that, because we have not given any time constant. What is the diode forward resistance? Nothing. We are saying instantly it is going to charge. That is why the examiner mentions that this word. What is this word? Steady state, right? Steady state means what? Don't think what happens at first quarter cycle. Just leave some 100 cycles and then think, right? Just leave for some time. Let him go to a state called what state? Steady state. So let the capacitor charge to 7 volt. And after that, what happens? Once the capacitor charges to 7 volt, when the diode is on, after that, the diode is going to remain reverse bias. Why is it reverse bias? You can see that your V0 is never greater than 3. Your V0 is never greater than 3. Your anode voltage is always here less than 3. It's always less than 3, which we have proved here. So the diode has to remain what bias? Reverse bias. So this guy is definitely reverse bias, right? So, okay, so which method is simple? The first one or the observation? Which one? Which one is simple? First one or the observation? Which one? Which one is better? Just by looking at the circuit, try to draw the waveform. So in all the problems, the examiner is going to mention find V naught in what state? Steady state, right? Okay, tell me what is the observation? Your V naught peak to peak is going to be V in peak to peak is going to be What is 12 minus of minus 12? That's 24. 24 volt. That is the first observation, right? The second observation is this diode, anode is at 6 volt, the cathode is at V0, and the diode should be reverse bias, right? When will the diode will be reverse bias? If the cathode is less than the anode, then the diode is forward, I told you. What if the cathode is at a higher potential than anode? Naturally, the diode will be reverse. So V0 should be greater than 6 volts for diode to be reverse bias. So two observations, right? One is your V0 is always above 6. Your V0 is always above 6, and that waveform which is above 6 is going to have a peak to peak value of 24, right? So that waveform which is above 6, that waveform which is above 6 volt is going to have a peak to peak of 24. What is 6 plus 24? 6 plus 24. Think about it. I'll draw the waveform. 6 plus 24 happens to be 30. Am I right? 30 volt. And what is 6 plus 12? 6 plus 12. What is 6 plus 12? That's the new DC, right? 6 plus 12. It's 18. 18 volt. Okay. So to what voltage will the capacitor would have charged? Tell me. So this happens to be what voltage? The capacitor voltage. Okay. Fine. How do we know that? How do we know that? This is the observation, but what was step 1 in the previous case? Step 1. Right? Find the capacitor voltage in steady state. But please, please, please look at the polarity of the diode. Is the diode forward bias in positive or the diode forward bias in the negative? The diode is forward bias in the negative cycle, right? So V in max is going to be maximum negative, which is minus 12. Or you can reverse the polarity and write plus 12, your wish, right? The diode is on, and here you have 6 volt. And there's a polarity for the capacitor. This is the direction. So give me a KVL now. KVL minus plus minus 6 plus VC plus to minus plus of minus 12 equal to 0. The capacitor is charged to 18 volts. So that's nothing but this thing, right? Okay, you can follow step 1, step 2 also, right? Fine. Anything you wish. And the second step, once that is done, what is the second step? The diode remains what bias? Reverse bias. So you have to just sketch the waveform, right? Just apply a KVL and sketch. You're going to get V0 equal to V in plus 18. V0 is going to be V in plus 18, right? Okay. Yeah, this 18 is the DC that you have restored in the waveform, right? Okay. What about the observation for this? You can see here, or logically, if the diode is on, this voltage is at minus 3. And what is the maximum voltage? This fellow, V in maximum voltage, it is minus 7. So what is VC? If the capacitor charges in this direction, VC minus 3 minus of minus 4. Minus 3 minus of minus. No, minus 3 minus of minus 7. What is minus 3 minus of minus 7 VC? Is going to be 4, right? So maybe it is 4. We'll see, right? So what's the observation? Observation is V0 peak to peak is V in peak to peak is what is 7 minus of minus 7? 7 minus of minus 7, that's going to be 14 volt, right? Second observation. Anode is at minus 3, cathode is at V0, and the diode should be reverse. Please, when is a diode reverse? Your VA, this is VA. This guy is VC. When is a diode reverse bias? If VC is greater than VA, right? VC should be greater than VA. That means -3 should be greater than V naught, or rather V naught is less. Your cathode should always be less than -3 volt. So how do we draw this? This is your V naught, and it should be less than -3. Right? So your V naught, no, this voltage, your VC, what is VC here? VC is cathode. VC is your V naught, V naught. And what is VA? This is VA, VA minus. Your V naught should be greater than -3. Your V naught should be greater than -3 for diode to be reverse bias. All right. So the waveform. And what is -3 plus 7? You're pushing that waveform up. -3 plus 7 is 4. So somewhere here you have 4. What is 4 plus 7? 11. What is 11 minus of -3? That's 14. Okay. So somewhere here you're going to get the waveform. Right. Your peak to peak voltage is going to be from above -3. So -3 to 11. Right, because 11 minus of -3 is going to be 14. Okay, okay. Your V naught has to be, V naught is nothing but your VC, right? Okay. So these type of problems, you'd have seen very frequently in GATE and IES exams, right? So sometimes in IES exam, they're given for 10 marks. So by looking at the circuit, you can tell the type of waveform at the output, right? Okay. So how do you know whether you have to do by transient analysis or directly the steady state? Transient, they will mention time, right? When they mention time, and they have to give the diode forward resistance also. So suppose diode forward resistance is 10 ohms, 20 ohms. What will happen for the capacitor voltage at t equal to 5 milliseconds, 6 milliseconds, like that? So if they mention time, then you will have to worry about what happens in the. So it's waste of time to think what will happen initially, because the examiner has not asked for time. He has asked only for what state? Steady state, right? So all these problems are for diode, are for V naught in what state? Steady state, right? Remember. So here your VC is -3 minus of -7, 4. And this is the 4 volt. This is the arrow here. Now, what if I give you time? Then you can probably see what happens, right? If I give you time, say for example, I give you time. Find VC at t equal to 3 milliseconds. Diode is still ideal. Yeah. So how do we do this? Find time t equal to 3 oh, I took 4 here, millisecond, but I want at 3, no problem. Now, in my first class, I told you, if you have a resistor, a capacitor, and you give some voltage V, right? Some voltage V, say 10 volt or whatever. This is RC. What will be the voltage across the capacitor VC? VC is going to be V into 1 minus e power minus t by RC. Do you remember? So this is the capacitor behavior, right? So the R and C values, what is R and C here? RC is 1K into 5 micro. That is 5 millisecond. 5 millisecond, right? Okay, but what do I want? I want at 4 milli. No. Time period is 4 milli. I want at 3 millisecond. 3 milli. First, we'll try till 2 milli. Because till 2 millisecond, half the period, the voltage is 10. And in the next duration, it's going to be at what? Minus 10. But what happens if I give a negative voltage to a diode? You know what happens. The negative voltage to a diode, that means the diode is what bias? Reverse bias. So the capacitor will still hold the voltage which is there till 2 milliseconds. So from 2 milli to 3 milli, it's just waste of time, right? It's just waste of time. So first we will find VC at 2 milliseconds, right? VC at t equal to 2 milliseconds. Is V into 1 minus e power minus t by RC. T is 2 milli, RC is 5 milli. V is 10 volts, right? 10 into 1 minus e power minus 2 by 5. It's going to be 2 by 5. Calculator. Calculators. Yeah, I think you can help me, right? So I'll just see in the comments section. Just give me the answer for this. You have calculators, you have cell phones, right? Give me the answer. 3.29. So many people have given. So many people said it's 3.29. So I'm going with that. 3.29 is approximately 3.3. Very good. 3.3 volt. So they say that at 2 milliseconds, it's going to be 3.3. What happens between when the time is between 2 millisecond and 3 millisecond? your Vin is going to be minus 10 volt. If you see the waveform is minus 10. So just tell me, if I give minus 10 volt here, and there is an R here, there's a diode here, there's a capacitor which is already charged to how much? 3.3 volt. What is the equivalent for such a circuit? Such a circuit equivalent is the diode is going to remain off because of the negative voltage here. See, anode should be positive and cathode should be negative. But look at the problem here. Cathode is positive, but anode is negative. It's completely reverse. So your V naught is at 3 milliseconds. V naught at 3 milliseconds is going to be V naught at 2 milliseconds is going to be 3.3 volts. 3.3. But what happens? Yeah, as a homework, you can tell me after how many cycles will at what time this fellow will actually reach 10, right? So maybe you know if your time is how many times of RC, right? So after few after few seconds, probably, right, after few milliseconds, this will almost reach 9.999 like that. And after that, your capacitor is going to hold that value, the peak value of 10 volt. So it's correct that it's going to reach 10. But when will it reach? Suppose if I say, what is VC in steady state? Tell me what is the answer. What is the capacitor voltage in steady state? The capacitor, when the diode is in this fashion, will charge to the peak. Will charge to the peak. So what is capacitor voltage in steady state? Right? Capacitor voltage, note, in steady state. So after few cycles, right, what will happen? Your capacitor voltage is going to reach 10 volt. Is going to reach the peak value. Is going to reach what value? Peak value. But the moment you switch on, just after 2 milliseconds, that's where the poor guy is charging, right? He's charging. What if there is no resistor? What if there is no resistor and I say that diode is ideal? Like how we have done in all the cases. What is tau? Your tau would have been probably, this is 0. The diode forward resistance is 0 because it's ideal. So the moment you switch on, it's 10. That's it. The moment you switch on, it's 10 volt. But I have intentionally put 1K here. And I asked you what happens at 3 milliseconds, right? So first it is 10 and then at minus 10. So when somebody asks you time, remember, when somebody asks you time, then you can solve in this fashion. But most of the problems in GATE and IES, they are in steady state. For steady state, 2 observations. Wait for a long time, let the capacitor reach a state called steady state. And once things have settled down, your V naught peak to peak is always going to be your V in peak to peak. Remember, right? Remember. Okay. 3.3, 3.3, 3.3. Everybody got 3.3. Very good, very good, very good. 3.3 volts. So somebody is saying that at around t equal to 0.5 second, right? So almost 0.5 second, half a second. Then after that, you don't have to worry. He says that V naught will reach 10 volt. Yeah. Can you suggest the best book for analog circuits is the question, right? So many books are there, especially, for analog, there's so many books. Cedar and Smith is one good book. Old edition you can follow, fifth edition you can follow. Cedar and Smith, right? And fifth edition solutions are also on the internet, so you can download. Um, then you have Donald Neiman, I think. Neiman and Neiman is also a good book. Microelectronics. Razavi is also a very good book, right? Razavi is a good book. But the thing is, follow one book, right? Just follow one book. Cedar and Smith is translated in around 20 languages, I think 20 other languages other than English, right? There are 20. So it's okay. It's a good book, right? Fine. Fine. VC1, VD1, VC1 and VD1 we already know, right? I think the same example I took here, 690. Yeah. So this is the first loop for that problem. So the first loop we already know the answer. You have to do the second loop. Of course, I'll do the first loop again, no problem. But you have to do the second loop. The first loop is already done, right? So you have to do the second loop. Find VC1, VD1, VC2, VD2 in what state? Steady state, right? The diode forward resistance is 0, so it's instantly charging. So don't worry about the transient dynamics. Don't waste time transient, right? Because there's no time here. In 0 time, it's going to happen. Okay. So let me do it. We'll take one loop at a time. During positive cycle, which diode is on? Which diode is on during positive? D1, right? But when D1 is on and the diode is ideal, what is the voltage across the diode? What is the voltage across these 2 points in a diode? These 2 points. It's a short circuit, right? So when it is short, the short is applied to VC2. The short circuit is applied to the D2 and VC2 in this loop. So don't think about VC2 when VC1 is charging because there's a short there, right? So as a simple analogy, right? You have to first see that VC1 is charging. And once VC1 is fully charged, D1 will become reverse bias. So first D1 is on, capacitor will charge. After the capacitor is fully charged, D1 will go to reverse bias. Then during which cycle VC2 is going to charge? Tell me. During which cycle VC2 is going to charge? This is VC1, right? During which cycle? Positive cycle, this is not possible. Negative cycle, yes, possible, right? VC2 is going to charge in the negative cycle and D2 is on, VC2 will charge. After VC2 goes to steady state, again D2 is reverse bias. Are you getting? So we'll go step by step. D1 on, capacitor charge. After capacitor charges, D1 off. D2 on in negative cycle, VC2 will charge. After C2 charges, D2 will go to what state? Steady state. So we'll take step by step. We'll go step by step, right? During positive cycle. What is the maximum positive input? Maximum positive input. 6 volts. Diode is on. So this procedure we have already done. So step by step we will do once again what is there, right? So okay, now we take a loop. KVL minus 6 plus VC1 is 0. VC1 is 6 volts. So first VC1 is 6 volts. After the capacitor has reached 6, not 5 or 4 or 3, if you reach 6, if you apply KVL to the diode, what will happen to the diode? This is Vin. The capacitor has reached 6 volts. And here I have a diode, right? Please, what is Vin? Vin can go anywhere between minus 6 and plus 6, right? Minus 6, minus 5, minus 4, minus 3, 0 also. We also have value 0, then 1, 2, 3, 4, 5, 6. So tell me what is VD1? What is VD1? Give me a KVL. Minus Vn plus 6 plus VD1 is 0. What is the clamper output VD1? It is Vn minus 6. The clamped output is going to be Vn minus 6. So let me write here. Your VD1 is going to be Vn. What is happening? Oh. So I can't write here. Okay. So your VD1 is Vn minus 6. What is Vn range? Minus 6 to plus 6. Your V0 range minus 12 to 0. Okay. So this is VD1 in steady state. So now you can see that your VD1 is the potential difference. VD1 is the potential difference across D1. When is a diode on? A diode is on when the potential difference anode minus cathode is positive. Now you can see that VD1 VD1 is minus 12. What is 6 minus 6? It's 0, right? VD minus 6 minus 6 is minus 12. 6 minus 6 is 0. So VD1 is always negative. Negative. So just tell me, I have a diode and my VD1 is negative. If my VD1 is negative, that means the diode is what bias? Reverse bias, right? So D1 is reverse bias. Okay, so let me repeat it once again. This we have seen in the clamper. First problem of clamper, once again. During positive cycle, D1 is on, VC1 charges to 6. After VC1 charges to 6, the diode should remain, there's no business for that diode. The diode can be replaced by open switch, right? When you replace by open switch, it is V in minus 6, and the range of VD1 is minus 12 to 0, so the voltage across the diode is reverse bias. Now, tell me when VC2 will charge. When VC2 will charge, is it going to charge in the positive cycle or the negative cycle? VC1, I told you VC1 will charge at this instant. Fully charge at this instant. At what instant VC2 will charge? Here VC1 charges, right? Here at this instant, your VC2 is going to fully charge, right? Negative peak because of the diode. So during, why did this come? Oh, yeah, where is that? This one. Go, 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 go. Oh my God. So how can I remove this? I can't. Okay, VD1 is V in minus 6, V in range, minus 6 to plus 6, VD1 range, minus 12 to 0, always negative. So the diode here, VD1, always negative, it is reverse bias, right? Okay, so what happens during negative cycle? This we have to see. During negative cycle, what is the maximum negative input? V in max. At that instant, it's going to be minus 6. This capacitor has already reached 6. Then let's go to this circuit, right? So we're going to see this loop here. Can you see this loop, right? Now give me a KVL around the loop. Give me a KVL around the loop. Minus to plus, or we can go like this: VC2 plus VC2 minus 6 plus of minus 6 equal to 0. So what is VC2 is going to be 12 volt. Or you can do one thing, instead of writing plus minus and minus 6, if you want you can even reverse the polarity. What happens if I reverse the polarity? This is plus 6 here. Here you can reverse minus plus and write 6. And then this is given to the capacitor. Your wish, right? You can directly see here, this is 6, this is 6. VC2 is going to charge to 12. But after the capacitor charges to 12, what will happen to the nature of the diode? Because here you have V in. This guy is already charged to 6. This fellow has charged to 12. And who is responsible for 6? D1. Who is responsible for 12? D2. So what happened to D2 after charging? After charging, do you think he's also reverse bias, like how we have done in the clamper circuits? So give me a KVL now, KVL. KVL clockwise, anti-clockwise, it doesn't matter, right? KVL, tell me. Plus 12 plus VD2 minus 6 plus V. So what is VD2? Minus of V in plus 6. Okay, so what are the final story, final answers? Final answers. VC1 is 6. VC2 is 12. VD1 is V in minus 6. And VD2 is minus of V in plus 6. So these are the four answers, right? We got, what is V in range? V in range minus 6 to plus 6. What is VD2 range? VD2 range. VD2 range is, substitute minus 6 plus 6, that's 0. 6 plus minus 12. So it's again minus 12 to 0, right? Negative, right? So again, it's going to be minus 12 to 0. What is this range here? Minus 12 to 0, same, right? So that means what is D2? This is VD2. VD2. It is also what bias? Reverse, because of the negative potential difference, right? So what I said is accepted. First D1 is on, capacitor will charge. After capacitor fully charges, the diode D1 goes reverse bias. Then D2 is on, VC2 charges. After VC2 goes to steady state, D2 will go to open circuit, right? Reverse bias. And please, I have to tell you that this is only a quick way of doing it, right? But actually this is not happening, right? We are taking one at a time and we are totally relying on the balanced equation KVL, because the algebraic sum of voltage in a loop has to be 0, right? But here, if you go into a little detail here, we will realize that if suppose D1 is on and VC1 is charging, right? We are saying that in the next cycle, in the next positive cycle, what will happen? In the next positive cycle, suppose this VC1 is charged to say 2 volt, right? In the first quarter cycle, say it is, okay, it's charged to 6. What is the guarantee that when VD2 is on, all the charge is coming only from V, all the charge is coming from V. Maybe VC1 is also discharging, who knows? Maybe there is a what you call sharing between C1 and C2. Then the voltage here, there, the charge formula, you know it, VC2 by C1 plus C2, VC1 by C1 plus C2, you have to do, right? But if you do it step by step and step by step, the same answer you might also get by first the VC2, the guy charges to 6, right? So VM. And then there is what you call sharing of charge, right? C1 by C1 plus C2. Then finally it's like VM by 2, then VM by 4, then VM by 8. So you will have to wait for a very long time, right? It's very long time. And then if you want, if you wait for a very long time, there's something like a geometric progression, right? So for a geometric progression, how do you solve? It's like A by 1 minus R, am I right? So it's going to be 2VM. So it takes very long time for you to do. Maybe you will have to do this till the gate exam, right? So VM, VM by 2, VM by 4, VM by 8, so on till infinity, right? That's okay. So this is fine. This is fine. This is fine. Okay. Shall we take a break? Shall we take a break? Yeah, we'll take a break and then we'll come back. A red arrow can undo. Oh. I didn't know that. Where was the red arrow there? Okay, fine. Next time, right? Okay, we'll take a break. When we come back, we will um, move forward, right? Thank you. Okay. Can you hear me? Yeah. Yeah. So during positive cycle, the diode is on, capacitor charges to the peak value, 6 volts. And then what is VD1? VD1 happens to be V in minus 6. VD1 happens to be V in minus 6. In the negative cycle, D2 is on, VC2 charges to 2 times of peak, 12 volt. And then after the capacitor is charged, VD2 is going to be minus of V in plus 6, right? So what is V in here? V in happens to be 690 minus 6, and this is minus of 690 plus 6, right? So in the negative cycle, I've taken a negative voltage here, or you can reverse the polarity and write 6, your wish. It's better. Let's not disturb V in. V in is V in. V in can also be 0, right? So let's not disturb V in. V in the place of V in, you can write minus 6, the D2 is on. Just apply KVL, you get VC2 12 volt. After the capacitor is charged, let's see what is VD2. We came to know that VD2 is going to be minus of V in plus 6, right? So any name you want to suggest this, any name you want to suggest this. In the previous examples, the capacitor was charging to peak. But now you can see that if you measure the voltage here as V0, if you measure the voltage here as V0, what is V0? V0 is going to be 2 times of peak, am I right? V0 is going to be 2 times of peak. V0 is going to be 12 volt, which is 2 times of the peak voltage. If I consider this as V0, right? VC1, VD1, VC2, and VD2, if you assume this V0, right? So it is 2 times of peak. So shall we call this as a doubler? Find VC1, VD1, VC2, VD2 in steady state for the voltage doubler circuit. Why is it called voltage doubler? Because the peak voltage is 6 volts and you're able to get 12 volt. You're able to get 12 volt here, 12 volt. So that is the reason it is called a doubler, right? Okay. It's called a doubler. Or can we collectively name this as voltage multiplier? Voltage multiplier, can we say like that? What do you mean by multiplication? Multiplication means product, right? V0 is n times of Vn. That's multiplication. N times of Vn, where n is an integer. N is an integer, right? So what if n is 1? Then V0 will be Vm. This we have seen. V0 is Vm. The circuit is a peak detector. Peak detector. If n is 2, V naught will be 2 Vm. The circuit is a voltage doubler or simply doubler, right? If N is 3, V naught will be 3 Vm. The circuit is a voltage tripler or simply a tripler, right? Okay, we'll see tripler now. If N is 4, V naught is 4 Vm. It's a quadrupler. If N is 5, V naught is 5 Vm. So I don't know, right? And 6, 7, like that. Collectively, we can call them as what? Voltage multiplier. You can increase the value N even to 100, right? Suppose your Vn is 230 volts AC, right? 230 volts AC. Vn. What is 230 volts? Is it peak or RMS? 230 volts happens to be the RMS value. So the peak is 230 into root 2, so that's around 315 volt or something. So if N is 100, if N is 100, but your VM is 315 volt, 100, you almost get 30,000 volts DC. That's a big number, a very, very, very big number, right? But please, can we keep on stepping up voltages like this? Can we keep on stepping up voltages like this? And 10 and 20 and 100 and 1000 like that. What's the limitation? The limitation is, remember the classic example of a transformer. In a transformer, what happens if you keep on stepping up voltages? Then the current driving capability of that circuit will reduce. If the voltage keeps on increasing, you know that the power is constant. Energy is neither created nor destroyed. So if you keep on increasing the voltage, then the current driving capability of such circuits will reduce. So where are these circuits used? What is the application of these circuits? Note, these circuits are used for high voltage, low current application, low current application. These circuits are used for high voltage, low current application, right? I need a support here. Yeah. See, we cannot call this as an amplifier because the output is DC, right? Your input is AC. So please don't call this as an amplifier. What can we call this? My input is AC, my output is DC. We can call this as a AC to DC converter. AC to DC converter. What's a DC to AC converter? You just give a power supply, no signal input, just the VCC supply, and then you get a sine wave. They are oscillators. They are what? Oscillators. An oscillator converts DC to AC. A voltage multiplier input is AC, but its output across the capacitor is DC. So a voltage multiplier is what converter? AC to DC converter, whereas an oscillator is a DC to AC converter. Are you getting, right? An oscillator does not have any input. The only DC is the source of power supply, right? Okay. Yeah, I was telling you voltage tripler. Find VC1, VD1, VC2, VD2, VC3, VD3 for the tripler. So what was the input in the previous case? Sine. We'll take cos. That's one and the same. What's the range of sine? -1 to +1. We can take cos. Cos t. What is the peak value of cos t? Peak value, right? 1, right? Cos t. Okay. During positive cycle. Please, during positive cycle, there's a chance that D1 is on and D3 is also on. Let's not go for charge distribution and then get a geometric progression. We are going to follow the balanced equation, KVL. The algebraic sum of voltage in a loop is 0, right? Steady state only. During positive cycle, D1 on, D1 on. Then what is the maximum positive input you're going to give? Maximum 1 volt. Capacitor cos t has a peak of 1. So what is VC1 when you write KVL? -1 plus VC1 is 0. The capacitor VC1 is going to be 1 volt. Now, what about KVL for the first loop? KVL for loop 1. Tell me what is KVL here? Minus cos t plus VC1 plus VD1 equal to 0. Or VD1 for any instant of time, your VD1 is going to be cos t minus VC1. But what is VC1? In steady state, your VC1 is 1 volt, so it's going to be cos t minus 1. This is something which we have already seen in the previous, before the break. I told you the first diode is going to give you Vin minus 6, Vin minus Vm. Now please remember, if the first diode gives Vin minus Vm, the third diode will give Vin minus Vm, the fifth diode will give Vin minus Vm, the seventh diode will give Vin minus Vm. If the second diode gives minus of Vin plus 6, the VD2 is going to be minus of Vin plus 6. That means minus of Vin plus Vm, VD2. VD4, the same value, minus of Vin plus 6. VD6, same value. VD8. So that pattern, the regular pattern is going to continue, right? We'll see that, but just observe there's no change. Your VD1 is going to be Vm minus VC, and VC is going to be 1 volt, right? So it's Vin minus Vm. So the same thing, it's going to be Vin minus Vm. There is no difference. Now, what happens in the negative cycle? Negative cycle, your Vin max is going to be minus 1. But the capacitor is already charged to 1 volt. VC2, right? You can go clockwise or at your wish, right? VC2 minus 1 plus of minus 1 equal to 0. So your VC2 is going to be 2 volt. 2 volt. So what is KVL for loop 2? KVL for loop 2. The second loop, you can see here the second loop. What is KVL for loop 2? Tell me. Okay, let me draw it here. Vn. This is already charged 2 volt. And here you have a diode. Tell me. 2 plus VD2 minus 1 plus Vn equal to 0. So your VD2 is going to be minus of Vn plus 1, minus of Vn plus Vm. Negative cycle, your VC2 is, so VC1 is charged to 1 volt, VC2 is charged to 2 volt. VC1 is charged to 1 volt, VC2 is charged to 2 volt. Any guess what is VC3? Any guess what is VC3? What is VC3? What is VC3? Any guess what is VC3? What is VC3? During the next positive cycle. Again, your Vn max positive maximum is going to be 1 volt. This capacitor is already charged to 1. This one is charged to 2 volt. And D3. What is VC3? Minus 1 plus 1 plus VC3 minus 2 is 0. Your VC3 is again 2 volt. There is no change in VC2 and VC3. So what is VC2? 2 volt, 2 times peak, 2 Vm. VC3 is 2 times peak, 2 volt. VC4, 2 volt. VC5, 2 volt. VC6, 2 volt. VC7, 2 volt, VC8, 2 volt. So it's always going to be 2 VM, 2 VM, 2 VM, 2 VM, 2 VM, right? So VC1 is, and what is VD3? VD3, how do you find VD3? You have V in here. Capacitor is charged to a steady state value of 1. This is charged to 2. And then this is charged again to 2. Right? Now, whether the diode is reverse bias or not, we have to check. But before that, what is VD3? After the capacitor is charged, the diode will remain reverse bias. So minus V in plus 1 plus 2 plus VD3 minus 2, 0. So your VD3 is going to be V in minus 1, which is nothing but VD1. So I told you, first diode, third diode, fifth diode, seventh diode, they all have the same voltages. Second diode, fourth diode, sixth diode, they all have same voltages, right? So your VD1 is, VC1 is 1 volt, VC2 is 2 volt, and VC3 is going to be 2 volt, right? Okay. Now the question is, why the name tripler? Why is it called? Because triple means 3 times, right? Why the name tripler? Why is it called tripler, right? Because we get 3 volts, right? But how do we get 3 volts? It's called tripler because you have V in here. This is 1 volt. Here you have 2 volt. Here you have 2 volt. So if this is 1 volt and this is 2 volt, what if we take output between the 2 points as V naught? Your V naught is going to be 1 plus 2, which is 3. It is 1 plus 2 is 3. That is why it is called tripler, right? If you take output only at the first capacitor, it is peak detector. If you take at the second capacitor, it's a doubler. If you combine 1 and 2, it's called a tripler. What about a quadrupler? If I have first capacitor only will charge to 1, then 2, then 2, then 2, then 2, so on. Here, 2, 2, 2 like that. Now you tell me, for understanding voltage multiplier, you should know tables, right? What is a table? You should know 1 1 1 1 What is 1 1 right? There's something my daughter, I've been teaching her, right? There's the easy table. 1 1 is 1. That is peak detector, right? It's peak detector here. 1 2 2, right? If we take 1 3 is 3. But when we teach multiplication tables, if they come by addition, right? So if you want 1 3 is 3, you have to combine these two. What's 1 4 right? 4 times the multiplication of peak is 4. So you combine these two for quadrupler. If you combine these 3, then 1 plus 2 plus 3. What is 1 plus 2 plus 3? That's a quadrupler, right? So it's, no, it's 5 times, right? Penta, I don't know, right? So 2 plus 2 plus 2, that's 6, right? Something like that. So odd multiples you can take up here, odd multiples. So you can have a line like this, odd multiples, even multiples you can have down, right? Something like that. Why the name tripler, right? Because 3 times. Okay. Yeah, there's some student is asking. So, give me a example, practical example. What example you want? Now, see, multipliers. I have used multipliers frequently, but it so happened that what's the a property of this multiplier, or rather the limitation of this multiplier is, even before I told you, even before I was a graduate, just after my diploma, I started working for Wiproji and I worked for Xerox also. So it so happened that at the customer's place, I found that when I went there, all the diodes are gone. I started thinking in a multiplier, why all the diodes have got burnt? Because usually when we go to a customer's place, a sensor will go, a relay will go, a transistor will go, a diode will go. But it's not like all diodes getting burned. There was some short circuit and all the diodes got burned in a voltage multiplier, right? So why did it happen? Because the property of a voltage multiplier is, if there is any short circuit, it's unlikely that only one diode will survive, because the diodes are connected in this fashion. Can you believe it? So if there's any short circuit here, a large current will flow, and the diodes that we were using had good thermal resistance. So it's unlikely that one diode will survive, like zoop, 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 zoop. It's like what in Diwali, what is that called? You have a bunch of crackers and then you burn one and all are gone, right? Something like that, right? Now, why is this pattern? Because this is the pattern you have in a multiplier. Because if I give V in here, if I give V in, the first capacitor we have seen, if you connect the first capacitor, then the capacitor is going to charge only to Vm, am I right? Yeah. And here you can connect the second one and third one, and there's a fourth one and the fifth one, and sixth one, something like that, right? So it's like a regular pattern. The first one will charge to Vm, and the second one are going to charge 2 Vm. The third one is going to charge to 2 Vm. The fourth one is going to charge to 2 Vm. And the fifth one. So if somebody asks you, in a voltage multiplier, what will happen to the 151 capacitor, right? 151th capacitor, what will happen? It's 2 Vm only. Only the first capacitor will charge to Vm, and all the other capacitors will charge to 2 Vm, right? Now, the first diode, you can see it's not down, it's up. The cathode is up. So if the cathode is up, the first diode, I told you it's going to be minus of Vin plus Vm, right? And this guy is going to be Vin minus Vm, right? So who is this guy here? This is D1 and D2 and D3 and D4 and D5 and D6, right? So this guy is like the first diode. This is equal to VD1, equal to VD3, equal to VD5, equal to VD7, and so on. This guy is going to be VD2, VD4, VD6, so on, right? So it's like a regular pattern. There's nothing great to learn here. Or if you want to cross-check, we can just find VD6 if you want. Can you give me a KVL round this loop? Can you give me a KVL? Round this loop like this. La 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 la, like this. Can you give me a KVL round this loop? I mean, just to tell you that your VD6 and VD2, everything is Vn minus Vm. Yeah. In this loop, just tell me minus Vn, minus Vm, minus 2Vm, minus 2Vm, plus VD6, plus 2Vm, minus 2Vm, minus 2Vm. So who gets cancelled? The minus plus gets cancelled. Minus Vn, minus 2Vm, and then VD6, and then plus 2Vm, plus 2Vm, and plus 2Vm. Yeah. Now tell me, the minus is going to get cancelled with plus, and this minus is going to cancel with plus. And then what is VD6? VD6 is going to be V in. What is 2 minus 1? 2 minus 1 is 1. Is V. Yeah. So you can see minus VM, minus 2VM, minus 2VM, plus VD6, plus 2VM, plus 2VM, and plus 2VM, right? It's V in minus. So please believe me, it's like a regular pattern. There's nothing great to learn here. The first capacitor will charge to peak, and thereafter all the other capacitors will charge to 2 times of peak. The first diode, if it's up, it's going to be minus of V in plus VM, 1 and 3 and 5 and 7, and then 2, 4, 6, 8, like that. So now you tell me, in this pattern, what will happen to 156th diode? 156, that's an even number. So even number, that means it's V in minus VM. What will happen to 255th diode? The 255th diode is going to be 55 is even, so it's minus of V plus V. Now please tell me, in the first problem when we did minus of V in 690 minus 6 or minus of 690 plus 6, what is the range? The range is always going to be minus 12 to 0. We have written here, you can see. So what is the range of V in? What is the range of V in? The range of V in range is going to be what? In range is going to be minus Vm to plus Vm. So your V naught range is always going to be minus Vm. So it's going to be 0 to minus 2Vm or minus 2Vm to 0. See, that's a beauty in this circuit. That's a beauty because the PIV, the peak inverse voltage across the diode remains 2Vm. It's always the maximum voltage that you can expect across the diode is 0 to 2Vm. The maximum is 2Vm. It cannot be more than 2Vm. So you can use the same size diodes and capacitors. Suppose if I agree with some of you, right, who have written in the comment section, first diode will charge to 1 volt, second diode will charge to 2 volt, third diode will charge to 3 volt, fourth diode will charge to 4 volt, fifth diode. If it happens like that, then what is the problem with that circuit? First capacitor, chota capacitor, last mota capacitor will be there. Are you getting? Because the PIV keeps on increasing. The beauty here is any loop you take, the diodes will only have 2Vm, right? The peak inverse voltage remains 2Vm for all the diodes, right? The PIV for diodes is going to be VPIV. Mod, you can take mod, magnitude, right, is 2Vm, right? It's always the same. Okay, right? So just keep in mind, right? Doubler is very, very popular circuit in exams. Tripler, I don't think so. But you should know, whether it's tripler or quadrupler, it's a very, very regular pattern, right? So all the diodes are gone. What do we call that? The comment section says that it's called a 1000 wala, right? Maybe, right? It's called a 1000 wala. Good comment. Okay. Sketch the transfer characteristics. Sketch the transfer characteristics. Okay. Now, what is the open circuited voltage here? If I just remove the diodes, what is the open circuited voltage here? This voltage is going to be Vin. Am I right? The open circuited voltage. There you have D1 here, and this node, you just open circuit here, realize that this VOC is Vin, and here you have 5 volt. This is D1. What about D2? Anode is at -5 and cathode is at Vin, right? So now you tell me, when is D1 on and D2 on? When is D1 on and when is D2 on? The diode is on if anode is more positive than cathode. If anode is more positive than cathode. If VOC is greater than 5 volt or Vn is greater than 5 volt, D1 is going to get on. D1 is going to get on. When D1 is on, So give me a voltage more than 5. Give me a voltage more than 5, say 6 or 7 or 8. What happens if the cathode is at 6 and the anode is at -6 in D2, right? So naturally D2 is reverse bias. So when D1 is on, your output is going to be 5 volt, right? 5 volt. Now, what about D2? D2. If the cathode voltage is less than the anode voltage, if the voltage at cathode is lesser than voltage at anode, then the diode is forward bias, or anode should be greater than cathode. It's one and the same. So who is there at the voltage at cathode? Vn is less than -5. Then D2 is on. D2 is on. D2 is on. So when D2 is on, when D2 is on, what is V0? V0. You can apply KVL. Plus 5 plus V0 equal to 0. Your V0 is -5, right? Now for all Vin greater than 5, your output is 5. For all Vin less than -5, your output is -5. Give me a voltage between 5 and -5. Give me a voltage between 5 and -5. Between 5 and -5. Okay. 0. 0. So what happens if I give 0 as Vin? If I give 0 as Vn, anode is 0, cathode is at 5, the diode is reverse bias. If your Vn is 0 for D2 and if anode is at more positive, cathode is at -5. So what happens in the third case? In the third case, if your Vn is anywhere between -5 and +5, both diodes are off. If both diodes are off, both the diodes have to be replaced by open switch. Then what happens? Then your V0 is going to be this VOC. VOC, and what is VOC? This is Vin. Your output is going to follow input. But the moment the diode gets on, the Vn or VOC or Vin is no longer there. It's either 5 or -5. So finally, how do you sketch the transfer characteristics? Vn on x-axis, V0 on y-axis. For all Vn greater than 5, your output is 5. That means y equal to constant. What is y equal to constant? It is a straight line parallel to x-axis, right? And here also it's the same. But here y equal to mx. So first we'll draw y equal to mx, but that is between what voltage? 5 volt and -5 volt. Between 5 volt and -5, your y is equal to mx. Y equal to mx. What happens when Vn is greater than 5? When Vn is greater than 5, your V0 is 5. If Vn is less than -5, your V0 is -5. So this is the transfer characteristics, right? The transfer characteristic says that what is the final result now for the transfer characteristics? For all Vn greater than 5, your V0 is 5 volt. For all Vn less than -5, your V0 is -5 volt. And for Vn between -5 and +5, your output follows input y equal to mx, right? So this is the final result or the transfer characteristic. So this we have got from a simple diode. We know when a diode is on and when a diode is off. And in all the transfer characteristics, the range of Vn is from minus infinity to plus infinity, minus infinity to plus infinity in all the transfer characteristics. Okay, but if you want a specific range, fine. Suppose if you want a specific range, what if your Vn is a sine wave like this, a sine wave? Suppose this is a Vn that I'm giving you, plus 10 and minus 10. You want a range, I'm saying. And the two voltages for comparison is plus 5 and minus 5. Then how are we going to sketch the output? How are we going to sketch the output? For all Vn, between minus 5 and plus 5, your output follows input. Your output and input both are same. Output and input both are same. What happens for Vn greater than 5? For Vn greater than 5, this is a portion above this line is greater than 5, your V0 is 5 volt. 5 volt. For Vn less than minus 5, your V0 is at minus 5. So this is like a bread, you take a bread and then slice it, right? So just take the middle portion. It's like a slicer circuit, or a double biased clipper, You can call this as a slicer circuit or a double biased clipper. Now, in the transfer characteristic, for all Vn greater than 5, this is the case 1 that I've written here. Case 2 is this, and the case 3 is this. Can you see, right? The third case says that output follows input. Now, what if in case 1, I want another slope, not just the slope of a line parallel to x-axis is 0, so I want a finite slope, some value. Or in case 2, I want another slope. How can I get a slope in case 2, in the case 1 and case 2 also? What change should I create in the question, right? What is the change that I should create in the question? If I want slope even in case 1, sketch the transfer characteristics. So I want a slope, so same problem I'm repeating. So by inserting a resistor, we can have a different slope instead of 0, right? Good. So this is my VOC here, which is Vin. So case 1, what happens when Vin is greater than, or your VOC is greater than 5 volt, or Vn is greater than 5. Or if you see in the previous example, we just took a diode and anode and cathode voltage. If you don't believe in this, you can calculate with current also, I told you, right? If you want to calculate with currents, then replace a diode with short, calculate the current. If the current is positive, then the diode is forward biased, right? Like that also you can do. So in this loop, what is I? I equal to Vin minus 5 by R plus R, which is Vin minus 5 by 2R is I. Now you tell me what happens if diode is forward bias, D1 is forward bias if I is greater than 0, means Vin minus 5 by 2R is greater than 0, your Vin should be greater than 5, right? So in the denominator, whether there is a 2R or a R or a 3R, if it's only one resistor or two resistors, three resistors, it doesn't matter in that series circuit. As long as Vin is greater than 5, there will be a positive current in that loop. So if Vin is greater than 5, the diode is what bias? Forward bias. Forward bias. Okay. Then what is V0? V0 is going to be, if you apply KVL here, IR plus 5. I is Vin minus 5 by 2R into R plus 5. So what is V0? What is V0? R gets cancelled. So it's Vin by 2. Vin by 2 plus 2.5. Your R is going to be Vin by 2 plus 2.5. It's of the form y equal to mx plus c. What is the slope m? It's going to be 0.5. So if you just draw a slope with 0.5, that's it, right? Same problem. Now what happens in case 2? In case 2, you have the same Vn, D2, but instead of 5, I gave minus 5. So naturally the current will flow in what direction? Opposite. All right. So what is V0 now? You can apply KVL clockwise or anti-clockwise, your answer is not going to change. If you apply KVL, then your V0 is going to be, just apply the loop, you will know, it's Vin by 2 plus 2.5 you get. In the previous case, it is plus 2.5. Oh, here minus is there. It is minus 2.5. And what will happen in the third case? Between minus 5 and plus 5, your V0 is going to be V. So it's simple. The same graph. There's nothing great here. It's the same graph, but for all V in between -5 and +5, between -5 and +5, there is a straight line as usual, right? Because if the diode is off, if the diode is off, your output follows input, right? But for V in greater than -5, what is the slope here? The slope is going to be 0.5. Similarly here, right? And the slope is because of the voltage division. If you have R and R, by voltage division, it's going to be half. What if it is 2R and R? Again by the ratio 2R by R plus R. If it is 3R and R, 3R by R plus R. So you can calculate that by the combination of resistors, you can have a different value of slope. Now, all of you, don't reverse the polarity of V in and write KVL, right? V in is always V in, but the value here, you have to put negative numbers. Here, what is the range here? This is valid for V in less than how many volt? -5. So please, you have to substitute negative voltages here. Give me some negative voltages. Suppose V in is -5. Can you see? This point should be satisfied now by this equation also. When V in is -5, tell me what will happen when V in is -5. So it's -5 by 2 is -2.5, -2.5, -2.5 is -5. It's correct. Are you getting? So your V in is -5, right? Similarly, this point V in +5, 5 by 2 is V in is 5, 5 by 2 is 2.5, 2.5 plus 2.5 is 5. So which is this point? Okay. And what happens if V in is 10? What happens when V in is 10 here? In the first equation, when V in is 10, 10 by 2 is 5, 5 plus 2.5, 7.5. When V in touches 10 volt, your V naught is going to touch 7.5. Similarly, when V in is minus 10 volts, right? So your V in is minus 10 volt. Minus 10 by 2 is -5, minus 7.5, minus 10 volts, minus 7.5. Okay, so it's valid, right? It's valid. Okay, sketch the transfer characteristics. This diode only, right? Sketch the transfer characteristics. Okay. Now, suppose this node is some voltage, right? Some voltage Vx or Voc, whatever. Now that voltage Vx minus 7, and Vx minus 3 here. So if you think that this voltage Vx is connected to Vin, this node Vx or Voc is connected to Vin, as I keep on increasing Vn, in the positive direction, out of D1 and D2, which diode gets on first? Out of D1 and D2, when Voc is increasing, which diode gets on first? Which diode gets on first? Very good. D2, right? You're right. When Voc is increasing, out of the two diodes, which diode gets on first? D2. Right? So let's see. Vin, what you said is correct. This is D2 and 3 volt. So what is ID2? ID2 equal to Vin minus 3 by 1K plus 2K, or Vin minus 3 by 3K. D2 is forward bias if ID2 is greater than 0, or Vin minus 3 by 3K is greater than 0, or Vin should be greater than 3. So what you said is correct. When I keep on increasing Vin, the first diode that gets on is D2. But for what voltage it is going to get on? Cathode is at 3, anode is at Vin. So this is getting on for Vin greater than 3 volt. For Vin greater than 3 volt. Now, what is V0? What is V0? V0 is going to be the resistor drop plus 3. V0 is going to be the resistor drop plus 3, or if you want, you can apply KVL. What is KVL here? KVL minus 3 minus ID2 into 2K plus V0 equal to 0, right? So from here you get V0 is ID2 into 2K plus 3. But what is ID2? V in minus 3 by 3K into 2K plus 3. This is V0. Oh, go away. V0 is this value, right? Or still can we reduce this? Oh. Still any value? The slope, what is the slope here? 2 by 3. 3 by 3 is 1. 2 by 3. 3 2s are plus 1, I think, right? V0. V0 is going to be 2 by 3 V in plus 1, right? You're right. When V in is 3, your V0 is 3. Okay. Fine. This is for V in greater than 3. So I mean just slightly greater. So the node is still there 3. So I'm just substituting in my mind whether I've done it correct or not. So when V in is 3, your V0 is 3. So from 3 plus, it's valid. It's valid with a slope M equal to 2 by 3. The slope M here is 2 by 3. Now tell me, as you keep on increasing V in, what is VOC? This is very crucial in this problem. What is VOC when D2 is on? If D2 is not on, what is VOC? If both diodes are off, what is VOC? If both diodes are off, VOC is V in. If both diodes are, let me make a note here. Oh, why did this come? Let me make a note. Note. If D1 and D2, if D1 and D2 are reverse bias means open circuit, then VOC equal to V. But if D2 is on, then VOC equal to, what is VOC if D2 is on? If D2 is on, you can see here, and here. If D2 is on, what is V0? V0 is going to be VOC. VOC is going to be V0. And what is the potential difference? What is the voltage across 1K? The voltage across 1K is going to be V in minus VOC or V in minus V0. There's a flow of current. Your VOC is going to be V0, right? Not V in. But when it is V in, when both diodes are reverse bias. Now you tell me, when will D1 get on? When will D1 get on? When will D1 get on? You tell me. D1, when does D1 get on? Tell me. When does D1 get on? So what is the answer now? What is the answer? Do you think when Vin is greater than 7 or VOC is greater than 7? When does D1 gets on? When Vin is greater than 7 or VOC is greater than 7? Vin greater than 7 or VOC equal to V0 greater than 7. Which is correct? Vin greater than 7 is wrong. VOC or V0 greater than 7 is correct. So let me substitute. I'll take this as equation 1. Substitute V0 equal to 7 volts in equation 1. in equation 1. What is equation 1? V naught is 2 by 3 Vn plus 1. So if you substitute 7 equal to 2 by 3 Vn plus 1. Yeah, now what should I do? So your V naught should be 7 plus. Your V naught should be how much? 7 plus. If your V naught is 7, then what is 7 minus 1? 7 minus 1 is 6. 6 threes are 18. 18 by 2, 9. Your Vin should be 9 volt. And the 2 volts is dropped across 1K. Your Vin should be 9 volts. 9 minus 7, 2 volts is dropped across 1K. So, case 2, if Vn is greater than 9 volt, D1 on, D2 is of course on, your V naught equal to, how much is V naught, you tell me? When this voltage Vin is greater than 9 volt, then this VOC is slightly greater than 7 volt. The diode is on. When the diode is on, this diode, of course, it is already on, right? It's already on here. 3 volt. What is 7 minus 3? 4. 4 is dropped across this resistor. What is V naught? V naught, because of the parallel connection, is directly going to be 7. V naught is going to be 7 volts. So now you tell me, what is case 3? What is case 3? The third case is when your Vn is between what voltage? 3 volt and 9 volt. When Vn is between 3 volt and 9 volt, right? Vn is greater than 3 volt and 9 volt. That is when you get the first case, right? The first case is true for Vn less than, between 3. I'm saying greater, but I didn't tell you the limit here. So this limit is, the case 1 is valid. This is case 1, right? What happens when Vn is less than 3 volt? If Vn is less than 3 volt, both diodes are off. If both diodes are off, what will be the value? The V naught is going to be 3 volt. So transfer characteristic says that for all Vn less than 3 volt, your output is 3 volt. Case 3. Between 3 volt and 9 volt, you're going to have a slope of 2 by 3, where it touches 7 volt. And when Vn is greater than 7, your output, 9, your output is restricted to 7. All of you, you know slope formula, right? So what is slope formula? Y2 minus Y1 by X2 minus X1. Just cross check. We know that slope M is Y2 minus Y1 by X2 minus X1. The slope is 7 minus 3 by 9 minus 3. 7 minus 3 is 4. 4 by 6. What is 4 by 6? 2 2s are 4, 2 3s are 6. So it's 2 by 3. So it's valid, right? This is valid. Let me substitute these 2 points in this equation. What is the equation here in the middle? Your equation is V naught is 2 by 3 Vn plus 1. Your V naught is 2 by 3 Vn plus 1, right? So let me cross check. So tell me, final result is for all Vn less than 3 volt, your V naught is 3. when Vin is between 3 volt and 9 volt, your V naught is 2 by 3 Vin plus 1. But when Vin is greater than 9 volt, your V naught is going to be 7 volt. This is when D1 off, D2 off. This I asked you, when is D1? So you said D2 gets on first, but the D1 is still off. This is when D1 is on and D2 is on. So 1, 2, and 3. Who is 1 here? Vin greater than 3. Vin less than 3. Vin less than 3 is 1. Oh, this is 1. Vin less than 3. Right? Less than 3 is 1, 2, 3. Right? So this is the final results. This is the transfer characteristics. Right? But generally, when I draw this transfer characteristics, some students have a doubt. What is the doubt? Because they have done the previous problem, they want to jump to a conclusion that for Vn greater than 3, D2 is on. For Vn greater than 7, D1 is on. But that is wrong. Why it is wrong is because of this statement. What is the statement? What is the statement we have made here? If D1 and D2 are reverse bias, then VOC is V. But if D2 is on, your VOC is not Vn, it is V naught. If the moment the diode gets on, there's a current flow. See how the patterns are changing, right? Initially, your V naught is 3, both diodes are off. Then D2 gets on, bang, D2 gets on. Then there's a linear relationship. And your VOC is nothing but your V naught, which is 2 by 3 Vn plus 1. So your V naught keeps on changing. When Vn changes, V naught changes. Vn changes, V naught changes. Then I substituted Vn as 9 volt. What happens in this equation? In this equation, when Vn is 9, what is 9 by 3? If my Vn is 9 here in this equation, if my Vn is 9, 9 by 3 is 3, 3 to the 6, 6 plus 1 is 7. So if you want 7 volts at V naught to switch on D1, your Vn should be at least 9 volts. Okay, if you say it is your Vn is 7, if Vn is 7, what does V naught tell me? If you say, okay, no, Vn should be 7. If Vn is 7, 7 twos are 14, 14 by 3, 14 by 3, 3, 4, it's around 5 point something. Are you getting? So your voltage is something like 5.4, some voltage. Then if your Vn gets 7, your VOC is just 5 plus. Then it is unlikely that D1 gets on. Are you getting? So this is a good problem. So please go through this problem once again, right? So let me summarize this one last time. My Vn, I'm slowly increasing from 0, 0, 1 volt, 2 volt, 3 volt, 3 plus. The moment I get 3 plus, D2 gets on. And then 4 volt, 5 volt, 6 volt, 7 volt. When I give 7, my VOC is still 5.4. So D1 is still off. Then 7, 8 volt. Then my VOC is still not 7. 9 volt. When Vn is 9, my VOC is 7 plus. D1 gets on. Once D1 gets on, your output is restricted to 7 volts. Your output is restricted to 7 volts, right? Okay. So as a homework, right? Homework. So we'll stop for today, but I'm just giving you homework. I just try to think about this and then I will solve this problem, right? Sketch the transfer characteristics. You can take a video on 0.7. You can take video on as 0.7 volts. Sketch the transfer characteristics. If VD on is 0.7. I'll give you a small clue, okay? The small clue is, imagine you have given a very large positive voltage, very, very large positive voltage, right? So some voltage, so like 1000 volts or something like that. If Vin is a very large positive voltage, out of D4 and D3, who gets on? Who gets on? Vin is a large positive voltage. Naturally, D3. When D3 gets on and D4 is off, then the cathode of D3 is also almost Vin because of the large positive voltage. So the positive voltage appears at the cathode of D3. Your D2 also gets off. So when you give a very large positive voltage, your D4 and D2 are off, okay? And your D1 and D3 are on. What happens when Vin is a large negative voltage? Imagine a large negative voltage, like large negative, like minus 500 volt. When Vin is minus 500 volt, what will happen? Which diode is going to get on, D4 or D3? Naturally D4. So D4 is going to get on, your D3 is off, your D1 is off, D2 and D4. So the pattern here is, if D4 gets off, D2 also gets off. If D3 gets off, D1 also gets off. That's how you get a breakpoint there, right? But there is Vin anywhere between some voltage. I'll not tell you what that voltage is. You have to calculate. So it's some voltage, then all the diodes might be on, and then your output can follow input, something like that, right? So think about giving a large positive, large negative, and try to solve this. I will do it next class, right? Okay, so we'll stop for today. You have any question and answers, you can ask me because I'm tired. Yeah.
Hello, sir.
Yes.
Sir, I have a request first of all. Could you please give us time to take screenshots or write down, sir? I think.
No, I was told that they are giving some this thing for you, right? They are keeping all the notes in the website. Is not true?
It is true, but sir, sometimes everything is not there, right, in those PDFs. So.
Then I'll do one thing. After every slot, see,
Sir.
it is good for me actually because.
Sir, everything is getting uploaded, sir.
Huh?
Everything is getting uploaded. Nothing is getting missed.
No, that is okay. But in fact, it is good for me. I'm saying, if you want screenshots also.
No, it consumes time, sir. Instead of we are uploading, it consumes time more than that.
Yeah.
We are uploading everything.
But to take screenshot, how much time do you need? I mean, like 1 minute. I can wait for 1 minute. It doesn't matter. No problem.
No, sir, even 30 seconds is enough, but
Yeah. That I'll do.
it's better if you change, if you tell before you change
That is okay. Acha, some students might be thinking and suddenly it goes to the next page.
Yes,
Okay.
sir.
I'll ask you to take a screenshot. Okay.
Yeah, and I have a doubt, sir.
Yeah.
This is actually I missed one class long ago. I just when you were teaching about the transfer characteristics, I know to find the transfer characteristics, but I don't know why we are open circuiting the diode for calculating transfer characteristics. Like,
See, I told there are two ways actually. One is a diode is on when it sustains a positive current. If you don't want open circuit, you short circuit a diode, take the current. When the current happens to be positive, the diode is forward biased. That we can see here. You can see here. See here. This is what the diode says. I'm not saying this is what the diode says. The diode says that if this is the diode characteristics, the diode says that if the current flowing through me is positive, then the voltage across me is 0, right? So that is in the segment 1. So what you can do, if you want to solve diode problems, you can replace diode by short and take a current. If the current happens to be positive, then the diode is forward. Are you getting? Now, this is one way. The other way is, suppose a diode is there, current, we are exploiting the definition of current here. What is the definition of current? We were told that the current always starts from a higher potential and then goes to a lower potential, right?
yes, sir.
So if this is anode and cathode, what if I open circuit and I check the anode and cathode voltage? If my VOC or VA is greater than VC, then also my diode is what bias? Forward. So you see, I mean, either way you can apply. For single diode problems, you can always take this simple risk, because calculating current means again what you call, you have to apply. See, suppose on VA I've given Vin, on VC I've given 2 volt. I am saying that Vin is directly greater than 2. But what does the textbook says that? No, first calculate current. Then we'll say ID equal to Vin minus 2 by some resistor in series or whatever will be there. So ID greater than 0, Vin is greater than 2. It's all one and the same. Are you getting?
Yes, sir. Doesn't it affect the open circuit voltage which we are calculating?
No. Open circuit, there is no current flow, no? You directly
Yes,
get
sir.
that.
So we are not calculating the resistor drops or whatever.
Resistor I've explained. Resistor will never demand any voltage. After whatever is left, the resistor will take. Suppose I've given this example also. Maybe you have not attended the class. I said, what if the voltage is 0.70000001? Then the diode will take 0.7. The resistor is going to take only 0.0000001. Suppose if you have given 12 volt, then also the diode will take 0.7. Leftover voltage 11.3 will be dropped across resistor. So what I was trying to say is, the resistor is only to see that the algebraic sum of voltage in a loop is 0. What is your job? Your job is to see that the input voltage is it greater than 0.7 or not. Don't think about resistor. He is not going to demand any voltage.
Okay, sir. Okay,
Hello,
thank you,
sir. Sir, good evening, sir. Sir, I have a doubt in page 16F.
Page
16F.
16, sir?
Yes.
Okay. 16. Yeah. Tell me.
Sir, here you have taken that 11 volt, rather it can come 14 volt now, sir.
Yeah, did I make a mistake? 11 minus of minus 3 is 14. Yeah. What is your doubt?
You have taken 11 volt. There can be there 14 volt is there.
14 volt, yeah. The peak to peak is 14. The input peak to peak is 7 minus of minus 7. That is also 14 volt. 7 minus of minus 7 is 14 volt. Yeah. Input is 14 volt. Output is also 14 volt. What is your doubt?
Sir, that I have only doubt in that 11. You have written that 11 volt, so I was little bit confused.
No, the swing is from minus 3 to 11, no? From minus 3 to 11, it is 14 volt peak to peak, no? This is 14 only. This is 14.
So the swing is taking place between -3 to 14. That is plus or -3, I think.
Yes. -3 to 14 is the swing limits with a DC of 4 volt. With a DC of 4 volt. 4 volt is DC. Oh,
Okay, thank
Good
you.
evening, sir.
yeah.
Hello, good evening, sir. Hello.
Evening.
Page number 22F, sir.
22.
Page number 22F, sir.
22F. Yeah.
Sir, here actually I am having a little bit confusion that how if means one end is having 12 6 volt, then how it is remaining, sir?
Hello.
Hello.
Hello. Yeah, tell me.
Hello.
Hello.
Hello?
You were asking something.
Sir,
If one is
actually
6, the other
here
one
in
is
this
12.
position,
The diodes are put in a fashion
in
where
this situation, why it is saying? Yes, sir.
hello.
Hello. Yes,
Yeah.
sir.
Tell me.
Hello.
Yes, tell me.
Actually, I'm
Is my
having
voice
doubt
audible?
in this position means it should. Yes, sir. Yes, sir. It is audible, sir.
Yeah, tell me.
Hello.
Yeah, take your time. Tell me.
Sir, in this situation, why we are saying? In this situation, why we are saying that it is still in reverse bias, sir? If one is having 12 volt and
No, first
another
is,
hand in 6 volts.
yeah, see, after the diode is forward, the capacitor is charged to how many volt? 12 volt. Then later on, it is going to be in reverse bias. The reason is,
Yes, sir.
just see the diode here. This is the diode. The diode anode is plus, cathode is minus, VD2. But VD2 value is from -12 to 0. Can you see here? It is from -12 to 0. What do you mean by -12? Why did I get -12? It is minus of V in plus 6.
Okay.
V in range is -6 to plus 6. So tell me, what are the numbers between -12 and 0? It can be -11, -8, -7, -5. The VD2 voltage, if it is positive, then the diode is on. But it is -12 or -11, -8, -7, -5, like that. It's all negative numbers. That is why. Are you getting?
Okay, sir.
Yeah.
So the highest value is 0 volt only, sir. Hello. Sir.
Hello,
Tell me.
sir.
Hello.
Yes.
Sir, I have doubt
Sir,
in
second
tripler.
doubt. Number 27.
Which page?
27, sir.
Sir, I have second doubt.
27. Yeah.
That in tripler. 26, sir. 26.
26. Yeah.
Sir, in
27
positive
F,
cycle,
sir.
YUR.
Sir, I'm having still.
Hello.
Yeah.
Sir, during first cycle, YU neglected diode D3.
No, we cannot. There's no need to neglect. But diode is ideal. What is the voltage across D1? What is the voltage across D1 when the diode is on? 0, no?
0, sir.
0 is applied for all the rest of the circuit.
Okay, taking parallel connection,
Parallel,
sir.
no? This node is connected.
Okay, sir.
Yeah. Okay.
Thank you.
Next.
Hello, sir.
Yes.
Good evening, sir.
Good
Sir,
evening.
12F, sir. Page number 12F.
12F. Yeah. Tell me.
Sir, not this one, sir. Like you have given 2 simple steps for clamped output, that thing, sir. There, we need to replace the diode by open circuit, right?
Yeah,
Open
this
switch.
one only, no?
Yes, sir. So, sir, here V0 is lesser than 3 volts you took, right, sir?
V0 is, if it is
Less.
greater than 3 volt, then the diode will be forward. It should be less than 3 volt for diode is reversed. You are absolutely right.
Like always we need to check at the cathode, sir. Like cathode should
You
be
have to
lesser than.
check the diode first. Cathode is already at 3, no? You are sketching V0. What is your focus? Your focus is on V0. V0, in which terminal is V0? Anode terminal. What should
Yes,
be the anode terminal? It should be greater than 3. So that is a clue. So when you sketch your answer, anode terminal should be greater than 3 for forward, but less than 3 for reverse. So that simple clue we got, that our output should always be less than 3. So from 3, all this waveform we have sketched down 3.
Okay, sir. If that is reverse, like mine.
Suppose you interchange the diode, the same diode you interchange, then what
Yes,
will
sir.
happen? Your V0 should not be less than 3, it should be greater than 3, no? Yes or no?
Okay, okay.
Then all the
Okay.
waveform you have to draw up, that's all.
Okay. If it is -3 volts, sir.
Page number.
Yeah, same. If the same position is there, -3 is there down, your V0 should be what? Less than -3 for diode to be reversed, no? Anode should be less than cathode. See, first of all, diode does not know if it is 3 or -3. Whatever anode voltage is there, that should be less than the cathode.
Okay, anode should be less than cathode, sir.
For diode to be reversed. Anode is V0, less than cathode. Cathode 3, 4, -2, -3, -5, your wish.
Okay, sir. And 30F, sir. 30.
30F. Yeah.
Sir, but here you have given condition cathode is less than anode, sir.
Where cathode is less than anode, no? That means this mouth is there at anode, no? That means anode is greater than cathode. Can you see here?
Actually, I'm getting confused, sir. Like when
No. When I say 4 is less than 5, can I say 5 is greater than 4? Yes or no?
Sir, 5 is greater than.
Yeah, 4 is less than 5. It means 5 is greater than 4. We are checking for diode on, no?
Yes, sir.
Yeah, wherever this mouth is there, that is greater. Anode is greater than cathode. For diode to be forward bias.
Okay, for forward bias, anode should be greater than cathode.
Yes.
For reverse bias, like
In clamper, this is clipper. In clamper problem where capacitors are given, anode should be less than cathode for the diode to be reverse bias. You are right.
Okay, that was I am getting confused, sir. Okay, sir.
Those are clamper capacitors are there, no? This is
Capacitor.
transfer characteristics.
Hello, sir.
Okay.
Sir,
Thank
I
you, sir.
didn't understand that statement. How high voltage multiplier are used for low current applications? Hello.
See, the power in a system is constant. Energy is neither created nor destroyed. If you keep on increasing voltage, naturally current driving will reduce, no? From where if I get more voltage and more current, that's not possible. A system will have power in a system is fixed. You design any device, its power rating is fixed, no? You cannot cross its rating. Suppose from that device, if you are drawing more voltage, you are keeping on increasing the voltage, stepping up, then naturally the current driving capability will reduce. See, it's a simple example, a multiplier, you can make a, what you call, a mosquito bat, yes or no?
Yes.
You can take a small battery. From your battery, they will give it to an oscillator, sine wave will come, that oscillator will give given to a series of diodes and capacitors. Then large voltage will come. Why that large voltage? Is only to give a shock to the mosquito. Why mosquito needs more current? Mosquito needs only one shock. High voltage is needed, and according to the resistance of the mosquito, the current will be drawn. Ohm's law, I equal to V by R. So you need large voltage. The load is the mosquito. So when nicely you prepare what you call the multiplier, voltage multiplier circuit, when you design, naturally suppose this capacitor has charged to 2 VM. Here they will short like this and make a bat. here like this. This. And now mosquito will come and sit here. These two probes are close by. Then there is some voltage here. Naturally, with this load, the shock will come. Are you getting?
Yes, sir.
Yeah.
Yes, sir. Thank you, sir.
Yes.
Hello, sir.
Yes.
Sir, I'm little bit confusing at slicer circuit, sir.
Slicer. Which page number?
Page number 32, I think, sir.
Two. Yeah. Tell me.
Yeah, I'm little bit confused at slicer circuit.
Yeah. See, when is the diode on? I'm asking.
Yeah, I
Diode
got
is
that
on.
procedure, sir. Last, how did you draw that?
Yeah, the waveform you want. See,
Yes,
this
sir.
waveform, the middle one says that y equal to mx.
Yes, sir.
Y equal to mx is a straight line passing through the origin. And then
Yes, sir.
the previous case says that V naught is 5. That means, however V changes, your V naught will always be 5. Y equal to constant. Y equal to constant is a straight line parallel to x-axis. So this is y equal to constant. So see, even if V in is 6 volt, your V naught is going to be 5 volt. V in is 7 volt, your V naught is low. So your V naught is always 5, irrespective of any variation of V in. V in is greater than 5. Your V naught is always 5.
Yes.
Yeah. In the similar case, in the other case, what is happening? When V in is less than -5, your V naught is -5. Are you getting?
And the circuits and the diagrams, sir, sine wave diagram.
Yeah, sine wave. Achha, where is
Yeah.
the sine wave? Did I draw a sine wave from?
Yes, sir,
Oh, this
32.
one. Yeah. V naught is V in. That means when V in is 1 volt, V naught is 1 volt. V in is 2 volt, V naught is 2 volt. V in is 5 volt, V naught is 5. V in is greater than 5. This portion is called greater portion. See, this line is 5 line. This portion is called greater than 5 portion. This portion is -5. This portion is less than -5. Above the line is always greater, no? On axis.
Yes. Yes, sir.
For all V in greater, your V naught is 5. For V in less than -5, your V naught is -5. Okay?
Yes, sir. At the page of 34, I think, sir. I didn't get that concept, sir.
Which one?
34. No, not that, sir. 2 diodes are in forward bias. Yeah, this one, sir.
Yeah, what concept you want? First I'm increasing V in from 0. 0, 1 volt, 2 volt. When both diodes are not there, this VOC is also V in. 1,
Yes.
2, like that. Then I asked you, out of these two diodes, which one gets forward bias? Some of you said that D2. Why D2 will get forward? Because cathode is at 3, here cathode is at 7. So naturally, which diode will get forward? D2.
Yes.
After D2 is on, will current flow or not?
Yes.
Current will flow. Then there is a relationship. V naught equal to 2 by 3 V in plus 1. So this is the relationship. Now, when V in, if my V naught here touches 7 plus, see this is V naught, no? When this is on, see here, this is V naught. V naught, V naught, V naught, V naught, V naught, V naught. When V naught touches 7 plus, then this diode D1 is on. So I substituted V naught equal to 7, I got V in equal to 9. When V in is 9, what is the drop across 1K? When V in is 9, suppose V in is 9, this fellow will be dropping 2, right? When this is 9, you have 2 volts here, 7. Your V naught is always restricted to 7. Try once again, okay?
Yes, sir. I got it.
Good, good, good.
Sir, I'm little bit. Sir, I have one more doubt. The forward bias means cathode should be anode should be greater than cathode, right, sir?
Perfect, perfect.
Yeah. Okay, sir. That was my problem.
Okay.
That's it, sir.
Right, right.
Hello, sir.
Yes.
Sir, can you go to 17F? Page number 17F. Sir, like for calculating 3 milliseconds, like we see at 3 milliseconds, why have we considered the 2 milliseconds?
Yeah, first we'll start with 0.
Okay.
1 millisecond, the voltage is still 10. 1.5 millisecond, the voltage is 10. 2 millisecond, the voltage is 10.
Yes,
But at 2.1 millisecond, the voltage is minus 10.
minus 10. Yes, sir.
So when you give minus 10 to anode of the diode, when you give minus 10 to anode of the diode, what will happen? Minus 10 to anode. The diode is going to get reverse bias. Am I right?
Yes, sir.
So there is no need for you to do from 2 to 3. Whatever
Yes,
2 is there, after that, there is no flow of current. The capacitor will hold that charge.
Okay, sir.
Okay, good.
Okay, sir. Thank you.
Yeah.
Sir, page number 27.
7F. Yeah. Tell me.
Sir, in this problem, why didn't we consider the D3 in the first positive cycle, sir?
That's what just now I told you, no? First student asked the same doubt. Yeah. When in the positive cycle, when D1 is on, diode is ideal. What is the voltage across D1, VD1, when it is short circuited? The voltage here is 0, no?
Total, sir, 1 volt.
0. The diode.
Yes,
When
sir.
the diode is on, it is short circuit. Naturally,
Diode,
the
yes, sir,
voltage
yes, sir,
across
yes, sir.
the diode is
0.
0. So 0 is applied
Okay,
for
okay,
the
okay.
next 2 loops. The next 2 loops, when you apply KVL, 0 only
Okay,
is
sir,
applied. How
okay,
they
okay,
can
sir.
charge? Are you getting what I'm saying?
Oh, yes, sir, yes, sir, yes, sir. Got it, sir, got it.
Good.
I got it, sir, got it.
Yeah.
Okay, thank you.
Good.
Hello, sir.
Yeah.
Sir, today starting problem.
Starting problem. This one?
Next one.
Yeah. Tell
Next
me.
problem, sir.
This is the first one, no?
Next problem.
This one?
This one, sir. In this, you combine two waveforms, sir, during positive cycle and negative cycle.
At any instant,
Two
only one
diagrams.
cycle we have to take. First, I took positive cycle, no?
After that, next page.
Next page. Huh? Yeah, tell me.
How this how that from the next problem, V out also there, no, sir.
Sir, not this problem. Next problem you want?
Problem only, sir. You combine both during positive cycle and negative cycle and calculated the V out, no, sir.
Yes.
Not understand.
Because once that capacitor goes to steady state, the diode have no business. You can remove the diode and put in your pocket. Because the diodes are reverse bias, no? The diode job is only to see the capacitor will charge. Positive cycle, D3 is on, capacitor is charged. Negative cycle, D2 is on, capacitor is charged.
Okay, sir. How should we draw the diagram of next page?
This diagram, how did I draw? Yeah, this is a simple
Next
diagram. I started from V in to capacitor
I
and then
understand.
diode. No?
Next diagram, next page diagram.
This one, huh?
This one, sir.
For this, what we have to do is, this diagram you should draw. Suppose you have drawn this whole diagram with a pencil. Then you have to take an eraser and erase D1, D2, D3, D4. When you take an eraser and erase D1, D2, D3, D4, then you will get this diagram. Are you getting it?
All the same,
For all cases, D2 is reverse bias. That means the diode has no business. So we have to remove those diodes. We have to take an eraser and remove all the 4 diodes. Then we will get such a diagram.
Okay, sir. 6F, sir. 6F.
6F, yeah.
In that, when we apply the positive,
Positive cycle, nothing will happen.
Positive-
Only in negative cycle, the diodes are on. Positive cycle, which
I mean,
diode is on?
positive cycle, D1 on.
D1 is on, but D3 is open, no?
D-
How current will flow?
Okay, sir.
Okay, in a series, they are in series, no?
Okay, sir.
Yeah, similarly, D2,
In 27,
page 20, yeah?
understand, sir. 27F, sir.
F, yeah.
27F.
This one.
Yes, sir. When we apply the positive cycle, third case, sir, for D1 also on, sir.
When we apply the positive cycle, how much voltage you are going to apply? Third case, V in. I have already told D1 range. What is D1 range? D1 range is cos t minus 1. It will go from -2 to 0. Cos t, range of cos t, range of cos t. -1 to +1. Range of VD1. -1, -1, -2 to 0. Tell me, with a -2 volt across VD1, can the diode be on? With a -1 volt across
No,
diode, can the diode be on? With -1.5, can the diode be on? With 0 volt, can the diode be on?
No.
Yeah, so the diode is off.
Okay.
Sir, I have a problem. Sir, what we are trying to see, the second observation, what we were trying to see is that when will the diode will be in reverse bias?
Yes. Because that is when you can add the capacitor voltage with the input voltage so that a clamping circuit value, clamping waveform is ensured. If you want a clamping waveform, you have to add capacitor with V in. And these diodes should not be in business because if the diode is on, only that DC voltage will come. Sine wave will not come.
Okay.
So our main aim is to add the capacitor voltage with V in. That can only happen when the diode is reverse bias.
Sir, we can also see it in this perspective. If the V0, जो V0 है, it can't exceed 3 volt. Sir, I also have a doubt, sir, that why are we calling it, why the name tripler? Sir, I was not able to hear it. So,
Acha, why the name tripler?
Yes,
Tripler
sir.
means 3 times.
Sir, that I got. Sir, why are we calling it tripler? Sir,
We are calling it tripler because we got 3 volt. We got 3 volt. There is 1 volt VC1, 2 volt VC2. You have to take a voltage here.
Okay, sir.
This voltage is 1 plus 2, which is 3. That is why it is called tripler. It's called tripler.
Okay. Sir, also I have a doubt. It's not a doubt, sir. I am trying to ask. Sir, that we are taking V in the negative cycle. We can use it in the negative half, or we can use it as it is and change the sign of the function.
Absolutely. V in can always be V in, but some capacitors will charge to positive, so you can write positive. Some capacitor will charge to negative, and V in also has 0 in it. Let V in be V in.
Okay.
But if there is a negative voltage, to measure it, you can reverse it so that KVL is satisfied.
Okay.
Or you can keep V in as -5 only. What is there? Yes or no?
Sir, last thing, sir, this is my first class. So, sir, if I have some doubt, so how can I contact you?
I have given my WhatsApp number.
Sir, Sir, tell me your number.
770
770
27
27
198
198
43.
43. Sir, what is your name?
My name is Kiran Kumar.
Kiran.
Kiran Kumar.
Kiran Kumar. Thank you, sir.
Kiran Kumar.
Thank you, sir.
Yeah.
Sir, can you please go to 18F page number, sir?
18F.
Yes, sir.
F. Yeah.
Sir, here I didn't understand the lower part, sir. 2 to 3.
Yeah. Between 2 to 3, what is the voltage we have to see? Let us see what is the voltage. See here. Suppose this is 1 volt. This is 2 volt. This is 3 volt.
Yes, sir.
So 4 millisecond. At 1 volt it is 10. At 1.5
Yes,
it is 10. 2 volt. At 3 volt it is minus 10, no? So your input is
Yes,
minus
sir.
10 at 3 volt. So you can connect minus 10 for anything
Okay.
greater than 2. Then the diode anode is at minus 10. The diode is reverse bias. Can you see?
What, sir? Sir, voice is not
Voltage.
audible.
This is the diode, no? Diode here, cathode is 3.3, anode is at minus 10. What will happen for this diode? This diode. The diode is forward or
Okay.
reverse? Reverse, no? It is not positive value, it is negative.
Yes, sir, yes,
Negative
sir.
is connected to anode.
Okay.
Yeah. Why
Okay.
negative? Because you can
Sir.
see the waveform. Can you see the waveform here?
Yeah, sir, but that I understood, sir. Yes, sir, that I understood, sir. But why we are calculating at 2
We
to
have
3 only,
calculated
sir?
only
We
till
are
2.
giving.
We have calculated only
Yeah.
till 2. See, it is something like this. Okay. For 0 to 2, for 0 to 2, there is a flow of current. Are you getting? There is a flow of current from 0 to 2.
Yes, sir, yes, sir.
But from 2 to 3 or
Okay.
2 to 4, there is no flow of current. Because the diode is
Okay.
what bias? Reverse. Can you see here?
Reverse
Open switch?
bias. Okay.
Yeah.
Yeah, I got it, sir. Thank you, sir.
Okay.
Hello, sir.
Yes.
Hello, sir.
Yeah, tell
30F.
me.
30F.
F. Yeah.
Previous one. 29. If we connected 9 diodes, sir, what is the output?
In which fashion? First one is facing the sky or the ground. That is more important, no? Where is this?
Same fashion. 29.
29, huh? Okay. Yeah. If you connect 9 diodes, 9 is an odd number, no? So first one is D1. D1 is minus of Vn plus Vm. Ninth diode also will be minus of Vn plus Vm.
If 8 means Vn plus Vm, sir.
8 means Vn minus Vm. Vn minus Vm. In this part here, if the diode is down, second one, fourth one, sixth one, eighth one. Can you see the numbers here? 2, 4, 6, 8, 10, 12. 1, 3, 5, 7, 9, 11, like that.
Okay.
Are you getting? These are, you can think like this. These are odd numbers. 1, 3, 5, 7, 9 are odd numbers. 2, 4, 6, 8, 10, they are even numbers. Are you getting?
Okay, sir. In 35, sir. Last problem.
Yes.
Case to output equal to 7 volts also.
No, if the diode is on, what will be the voltage here? Suppose the diode is on here. This voltage is 7 now with respect to ground here. 7, no? It is 7, it is 7, it is 7 only. It's the same 7. Once the diode is on, the output is 7. But Vin should be at least 9 volts to get 7, which you can get from this equation. In this equation, substitute V naught equal to 7. Your Vin should be 9, no?
Okay, sir.
Yeah. See, this is something like this. You can visualize it like this. See here. I'll tell you. I am having Vin. There are 2 resistors and 3 volt. As I keep on increasing Vin, 3 volt, 4 volt, 5 volt, 6 volt like that, then current is going to flow, no? When current is going to flow, naturally this voltage will not be the same Vin, because Vin is there. Vin minus of this drop will be here, VOC, this drop. But once that drop touches 7 volt, this one touches 7 volt, bang goes the first diode. The diode is going to get on. But to get 7, you have to give at least 9 volt here. How do I know? When you remove this, you will realize that your output and input relation are 2 by 3 Vin plus 1. So when Vin is 7, your V naught is only 5.4. When Vin is 9, your V naught is 7. Vin is 9, then your V naught is going to be 7. Are you getting?
Okay.
Yeah. Next. Yeah, tell me.
Sir, good evening, sir.
Yeah.
Sir, I just have a general doubt. In the starting sums which we discussed today, where 4 diodes were there with 2 capacitors across them.
Yes.
Sir, when practically designing such circuits, we should even consider about the voltage ranges which we are using, right?
Yeah. Because see, when capacitors are there, power rating will be there, the voltage rating also will be there. Yes, you're right.
Yes, sir. Why I got the doubt is during all this analysis, we did not consider anything about breakdown voltage, no, sir.
No. Yes, we have always felt that these capacitors are strong enough. The diodes we are using also, they are strong enough to sustain such voltages.
Okay. Sir, and in the circuits which we drew today, if there was a load resistance connected across, we are calculating V naught across open terminals. If there was a resistor RL, then the analysis would also be changed, right, sir?
RL where? In which circuit?
In the
Clamper
starting
or clipper?
No, in the starting circuit, sir, where we have
naturally, that means you are providing a discharge path for capacitor, no? Yes, it will definitely change.
Then the analysis won't be like what we did today, no, sir?
Yes, you are right. Okay. Because once the capacitor goes to steady state, then after that, if you put a resistor in between, then naturally there will be a transfer of charge from one capacitor to other, no?
Oh, okay, sir. Sir, and voltage multiplier explanation was so good, sir.
Thank you so much.
No, long back I worked on Marx generator project, sir, where we tried to get high voltage spark at the end.
Yeah.
Yeah, sir. So this explanation.
How much voltage? How much was the voltage?
4 kilovolt capacitors we used.
Oh, yeah. Like you get the corona effect then. Almost green light.
Rating was so low, sir, 0.045 picofarad or so.
Okay.
And we went nearly for 9 stages.
Wow. Oh, that's good.
We just tried for fun to see some sparks, sir. So the same concept was linked here, and it was so good, sir.
Good. Thank you.
Thank you.
Sir, good evening, sir.
Yeah.
Sir, today we have solved three kinds of problems and finding V naught in steady state and VC1, VD1 and transfer characteristics. Sir.
Yeah.
Sir, I understood calculation of V naught, but I have a bit confused in calculation of VC1, VD1 and transfer characteristic. Sir, can you give us one clarity that how we can deal with these kind of problems?
So which problem you are saying?
No, sir. How we deal with those problems, sir?
That is how
initially?
we arrive at them.
Yes, sir.
Step by step only we have to do. I mean, you are almost halfway through, no? So you don't have to worry. You're almost halfway through. Depending on the type of problem, you can make an analysis. But here, do you have any circuit you have where you have a problem in today's class?
Sir, in 35F, sir.
35F, you have a problem. Okay, so such type of problems. Yeah, this one.
Sir, I understood, sir. First, I was thinking that D1 will be on if 7 volt greater and D2 will be on 3 volts. Sir,
that is the only reason I have given this problem. The reason is, see here, okay, just to convince you, I am telling you, a diode is on only when the current flowing through the diode is positive, no?
Yes, sir.
This is Vn. Here this 1K. If you still have an element of doubt, I am saying, let us take a current here. If the current is positive, the diode is forward, no?
Yes, sir.
Yes or no?
Yes,
so
sir.
just to convince you, this is 2K. Yeah.
Yes,
now
sir.
this is my current ID1. Now this node is 7. You can take some Ix here and Iy here. Diode is on only when the current is positive. So you can take Ix next time. Next time you have it. You are saying, no, sir. For such type of problems, I am having a problem, right? So to relieve you of that problem, I am telling you. Next time you find such circuits, by looking at that circuit, if you are not able to analyze, you do by general method. What is the general method? Entering current equal to leaving current.
Leaving current. ID1 plus I.
It's Vin minus 7 by 1K. Leaving is going to be 7 minus 3 by 2K. Here, ID1 greater than 0 means your Vin will be greater than 9, if you saw.
9. Okay, sir. Yes, sir.
So next time you have such problem, the only thing what you can do, if you have an element of doubt, replace diode by short. Take a current. If the current is positive, then the diode is forward. Is it okay?
Yes, sir. Sir, in clamper problem, you are taking output at diode, na, sir? Is it correct?
Not across diode. Across the one node is at the capacitor, the other for ground, no?
Yes, sir.
Yeah, either anode or cathode of the diode. But we want Vin, and you want to sketch across diode also? Diode with DC source, both together.
Sir, in first clamper problem, I didn't remember the page number. Sir, you flipped the diode towards output.
Yeah. Towards output, yes. So across the diode only, you are right, across the diode.
Okay, sir.
Yeah.
Thank you, sir.
Okay.
Hello.
Yes.
Good evening, sir. Sir, can you go to page number 12F?
Page number 12F. Yeah.
Sir, can you explain this observation part? I didn't get, sir. I'm getting that long procedure, but I'm not able to do through this observation.
Okay. No. First observation, is it okay for you?
No, sir. That also I didn't get.
No. What is peak to peak? Peak to peak means you have to do the difference.
20 volts. Okay,
20.
sir. Yes,
peak
sir.
to peak is 10. Minus of minus 10 is 20.
Okay. 20 volts.
Yes or no? So
Yes,
the
sir.
output should also have 20.
20. Okay.
Positive peak minus negative peak. That is first one.
Okay,
Second one, but I'm not drawing it. I'm just telling you what it means. What is the meaning of these two? Are you getting?
Yes.
So the meaning is, if I take positive peak and subtract with negative peak, I'm going to get 20.
Yes,
Output also, it is expected that positive peak minus negative peak will be 20. But we don't know what is positive peak and what is negative peak. Are you getting?
Yes, sir.
So now the second observation is, suppose if I want to draw an output, I have to combine Vin with the capacitor. This diode has no business.
Yes,
the diode should be reverse bias.
Yes,
so anode voltage is V0, cathode is at 3. When can a diode be reverse? If anode is greater than 3, the diode is forward.
Greater than 3? Okay, then it will be reverse. Yes, sir.
So it should be less than 3 for reverse. Greater than 3 for forward, less than 3 for reverse. So your V0 should be less than 3. So then what did we do is, finally, we have taken, see here. Yeah. So finally, what did we do is, we have taken a graph like this and said 3. This is 3. Okay. Now my answer should be less than 3, no? Yes or no?
Yes, sir.
But here I am having a waveform like this, a waveform. So what did I do now? I'm catching this end, and pulling this here.
Yeah. Okay, sir.
So this is 10. This is minus 10. Just you think that this is my hand, okay?
Yes, sir.
Can
Yes.
you see my hand here?
Yeah, sir. I can see.
So I'm just pushing it like that. I'm just.
Yeah. Okay, sir.
Are you getting? So this
Yes,
I'm
sir.
pushing it down here.
Yes.
Are you getting?
Yes,
so
sir.
now,
Got it, sir.
what is 3 minus 20? It is going to be minus 17.
Minus 17.
Minus 17. That's all.
Yes.
So clamping
Thank you.
means just catching that and pushing it up or down.
Yeah, okay, sir. Thank you so much, sir.
Okay.
Hello.
Yes.
So I want to ask some second class or third class. You said that when we will give step input to any capacitor, then you just made the graph across voltage that charging one.
Yes,
Right.
yes.
And when in a Miller integral that there was a circuit now where is steady constant
Because
voltage.
there is virtual ground, the current is V minus 0 by R. The current is constant. When a constant current flows to capacitor, there is a constant current to a capacitor. The capacitor voltage is 1 by C integral IDT. Current is constant. You can remove outside the integral I by C of t. So capacitor will charge in Y equal to mx in Miller integrate.
So, but in earlier also there was constant means unit step.
No. They exponentially decaying. This is 5 volt. This is suppose 1K and capacitor. Now this is capacitor. What will happen if I close the switch? If the capacitor is 1 volt, the current is the capacitor. There is no current constant. Capacitor is 1 volt. Current is 4 amp. Capacitor is 2 volt. Current is 3 amp. Capacitor is 3 volt. 5 minus 3 by 1, 2 amp. Capacitor is 5 volt, 0 amp. Capacitor is going from the VC is 0 volt, 5 amp. So capacitor is charging from 0 to 5.
Okay, that
And
means
current
it's dependent
is
on current.
exponentially decaying. So what is integration of exponential function? Integration of exponential is exponential.
Yes.
Integration of constant is ramp. It is exponential here. But if you take the same RC network and put for op amp, then op amp will nicely put 0 here. Then you will have only V by R current, constant current. This will flow through capacitor. Capacitor will charge in linear fashion. Are you
So
getting?
means it is only depending on current. When the current is constant.
100% op amp is setting up Z. See, if previously it is 5 minus VC by 1. It is 5 minus VC by 1. You know what is op amp doing? This node virtually 0. 5 by 1, 5 amps current. That is going to capacitor.
Okay.
This node is virtually 0, no?
Yes, sir. Yes, understood.
Yeah.
So, in the op-amp question, why it is written Miller integral?
Because the capacitor is floating, no? Any capacitor resistor that is not grounded is called Miller's resistance and Miller's capacitance. And capacitor is basically integrator, no? 1 by
Yes,
C
sir,
integral
yes,
I.
Yes, sir.
Yeah.
See, I'm little bit confused in Miller means whenever the input is at inverting terminal, then only we have to apply.
See, that is why you will get this doubt. That is why I told you, don't worry about that. A resistor is there between V1 and V2. What is the input resistance here? This is going to be R divided by 1 minus V2 by V1.
Yes, sir.
This is going to be R by 1 minus 1 by V2 by V1. Inverting, non-inverting, forget it. Okay?
So means feedback from the inverting terminal and sources in non-inverting terminal, then also
Where the source is connected, there only you will see now. If source is connected to non-inverting and current is 0, then you have to say it is infinite. What can we do? Current is 0 now. If you suppose there is a Miller resistor here, okay? Suppose this node, and here I am finding my input resistance. What should I do to this resistor? I am saying, and my job is only to calculate through non-inverting. Then if my current is 0, my resistance is 0, why do I worry about Miller effect?
And sir, virtual.
But if I have a resistor like this, and then I have a resistor here, then I can apply Miller.
It means when there is source, then only we need to apply.
No. Resistance means, according to Ohm's law, resistance means the source voltage divided by the current drawn by the source. That is Ohm's law. R equal to V by I.
Yes, sir.
There you are connecting the source, there you are calculating resistance.
Yes, sir.
Suppose I connect non-inverting, and if I say at inverting terminal there will be Miller effect. There will be Miller effect where you want to find.
Oh, okay.
I am finding at non-inverting. I am connecting V. Whether there is Miller effect or not, I don't care. Ohm's law says that first calculate V by I, then talk about Miller. I is 0, resistance is infinite, finished. Are you getting?
Yes, sir.
Where you are calculating, that is important. Suppose I am calculating here. Here you can do V by I. Or if you remember Miller theorem, you apply Miller theorem. Suppose Miller theorem, sir, I don't want to remember Miller. Don't remember. Just do V by I. That is resistance. Are you getting?
Yes, sir.
Don't remember Miller. What is it?
Sir, and
Now
that,
Miller effect will be there because you are seeing through a port where the resistance is connected. Are you getting?
yes, sir, and that virtual ground concept is also related to Miller's effect.
Yeah, we can relate it. So because R by 1 plus A is there, no? If A is infinite, what is R? 0.
Yes.
So it's like virtually 0 resistance at inverting terminal.
Sir, and one more doubt. When there is a simple op-amp circuit like feedback of 9K and that inverting terminal 1K and some voltage, but the gain is some finite 2 or 3.
Then V0 is A times of V1 minus V2 you have to apply.
So that's all.
Yeah. That's how I started op-amp.
Yes, sir.
I will do such problems in non-idealities of op-amp, last topic. There I will do CMRR, slew rate, finite gain problem, finite input resistance problem, finite output resistance problem, finite gain with finite input resistance, finite gain with finite output resistance, everything we will do. Okay.
So you concept wise it was very clear that current division and voltage division. I can explore new techniques to solve questions.
Very good. Yeah. Yeah, what can we do? Shall we stop? We'll wind up for today.